Hack the planet! Hack the planet! We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat. And we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're going to be covering today in today's stream. And let's begin. All right, so in each one of these streams, we tend to cover 4 topics. That is the usual thing we do. And today is Linux Monday. If you're ever wondering where our stream schedule is, you can find it over in our Reddit over here. You can also find it on our Discord. If you're interested in joining the Discord, you can join from this link over here. Okay, so what are we doing today? So the first topic of the day, the first hour, we're going to be doing RingZeroCTF, and this is a CTF education platform. You can sign up for an account for free over at this link over here if you want to join along with us. And we're going to be doing some cryptography challenges over there. So we've been learning about cryptography, and in the second hour, we're going to be continuing with our cryptography lessons in HackerFrog AfterSchool. So this is going to be the last session we're going to be doing for cryptography, but we're ending off with some fun stuff. We're doing some XOR operations as it pertains to cryptography and one-time passwords. So that's going to be a lot of fun. We're going to be doing that in the second hour. In the third hour, we're going to be taking a look at the CmdChallenge website, and it's a fairly simple website, but it's a place where you can. Bitzilla says about to play Arc Raiders and get the goop. The goop? Is that what you get in Arc Raiders? Hope you have a lot of fun at Bitzilla. And Jason, hello, nice to see you here. What is up with you? And yeah, so Command Challenge, I just left the link over there. It's a fun little website where we have to challenge your Linux skills in order to beat some challenges. So we're going to be doing more of those over there in the third hour of today's stream. And in the fourth and fifth hours, we're going to be doing our Advent of Cyber warm-up. So TryHackMe does an event every year during December from the 1st until the 25th called Advent of Cyber. It's a lot of fun, and it introduces people to a lot of different cybersecurity concepts. We're going to be doing some of the challenges from previous Advent of Cyber challenges to get ready for the event. Okay, listen to this while you go get the riches. No worries, I hope you get those riches. Okay, let us upgrade. Are we upgrading? From what to what are we upgrading? All right, so without further ado, we should probably get into our first topic. It's going to be about 60 minutes of cryptography fun. Let's go ahead and put that timer on. All right, it is working, and let's go ahead and get into those cryptography challenges. So while we're solving the cryptography challenges, we'll also try to, what is the word? Write documentation, because in cybersecurity, they say if you didn't document it, it didn't happen. So here is the link for the challenges, and we're going to be doing some of the cryptography challenges. Let's go ahead and start those. So we previously were working on this, I think a couple of streams ago, and we managed to finish something in the neighborhood of 3 cryptography challenges. And let's go ahead and do the next one. So let's see, RingZero Cryptography. Yeah, we did 1, 2, 3, 4, 5 challenges last time. Z Detrimental, hello, nice to see you here. Finally able to catch a stream today. Welcome in, Z Detrimental. And you know, just for fun, let's give you a fun little video redeem. How about a Nyan Cat, just for you? Okay, so let's start our first challenge. So if you don't have an account over at RingZeroCTF.com, you can make one. And let's see, the next one we're going to cover, how about we do this one called Martian Message Part 3. So there've been a series of these challenges. Let me log in first. Bitzilla says, new listener here, have you always been into cryptography? How many years have you been doing it? Cryptography is actually my least well-developed cybersecurity discipline, but I think cryptography is a very necessary concept inside of cryptography and the internet. Well, sorry, inside of cybersecurity and the internet, because you need cryptography to keep your information safe. So if you guys want to join along with us, Jason says, nothing much. Listen, let's not talk about adult topics on the stream. This is a family-friendly stream. Thank you, Jason IT Solution, for not mentioning those topics. Anyways, all right, so we've got our encrypted string over here, and what we want to do is we want to decrypt the message. So let's go ahead and start the write-up. Okay, and let's see, it's going to be a markdown file. If you ever wonder where all of our walkthroughs go, I'll leave a link to the walkthroughs in just a second. All right, so for each one of these challenges, we're going to be noting a few different things. So one is the URL where you can find the challenge. The second thing is the concept that you need to understand to finish the challenge, and the method of solving the challenge. So the first one is the URL. You can find it over here. Let's go ahead and record that. The concept, we don't know what this particular ciphertext is. So we should probably take a good look. So this looks like, I'm not exactly sure what kind of cipher this might be. So when we're talking about cryptography, there are a bunch of different methods of encrypting and decrypting, well, encrypting and decrypting messages. And one thing that we can turn to for identifying what kind of encryption method might be used is this website over here. It's called decode.fr. And they've got, you can go ahead and get a English version of this website. If you want to take a look at it yourself, you can take a look at it over here. So what we can do is we can use the tool over here called the cipher identifier. And the cipher identifier is going to make its best guess as to what kind of encryption is being used when we give it an encrypted string. So let's go ahead and grab that encrypted string. It's over here. And then we will see if this tool can help us out. Okay, paste it in. And then click on Analyze. Okay, so this is text says short length base 32. So base 32 is one of these. It's not necessarily an encryption method, but it is an encoding method. So base 32 encoding, I guess what we could do is, well, if you've got a Linux terminal, you can use a couple of native commands here. Base 32, yeah, okay, and we can decode from that. Echo out the message. And decode that. It says invalid input. Invalid input. So the other thing that this could be is it could be base 64. Actually, wait, we'll do this with the invalid input. Okay. What about base 64? This is another encryption method. This gives us readable, something legible. So this could be a message that's encrypted multiple times using different methods. So we see here that this is not base 64 encoding. This might be something else. Another common tool we might use is called, what is it called again? It's called CyberChef. So CyberChef is a website that a lot of tech enthusiasts use. You can apply different encoding or encryption methods to some data, and this is what we're going to do here. Okay, so what we can do from here is we can apply a few different, kinda geeky, hello, nice to see you here. Welcome to the stream. Okay, so we can apply some different operations to this string, and I think what we can want to do is we want to do from base 64. So from base 64, we get this data here after it's been transformed using base 64. And I wonder what this might be identified as. If we go back to the cipher identifier here and we paste in this, we'll analyze it. And let's see, ASCII shift cipher. ASCII shift cipher. It doesn't seem very confident about this, but I think this might be another type of ASCII encoding. And there's a certain ASCII encoding, I think it's called base 85. I wonder if it's here. Base 85, it's here. Okay, so we will do it from base 85. From base 85 here. Okay, and then we get still more encrypted stuff. So I'm not too sure. I'm not too sure what the actual encryption method is for this challenge. If anybody has any clue what it might be, I'm open to suggestions in chat. So this first encrypted message here, when we analyzed it, magic operation. We could try the magic operation. That's true. Matches. Nice to see here. And yeah, so magic is basically CyberChef trying to do an automated encryption or decryption in this case. So let's give magic a try. Okay, and so we see base 64 being applied and base 58 from base 58 from base 64. That's interesting. So if we base 64 decode this, we get this, but is there like a base 58 command? Yeah, there is a base 58 command. Let's give this a try then. 58. Okay, those are not printable bytes, so I'm not too sure that is the correct one to use. But we also got this over here, base 32 Crockford, which is, I've never heard of this particular variation of base 32. String of printable characters. All right, let's grab that. We'll paste it in. We'll give it a try. And we get just not printable characters. So if whatever comes out is not a printable character, we can't really rely on that. The other thing that we could do is we could go over to the challenge itself and see if it offers some sort of clue. There are no clues. Okay. Well, I guess So the previous challenge that we did, it was encoded a couple of times. Martian message part 3. I wonder why. So everything in here is called Martian message. The first one had to do with, what was it called? Caesar cipher. So that was Caesar cipher. The second one, let me check the second one. So the second one, we will RingZero. That was cryptography. Martian message 2. And that was Vigenaire cipher. So we're given a cipher string as well as a key, and we did that with the web app. But in this case, I'll just paste in the ciphertext just in case anybody wants to give this a try. So that's in chat now. Okay. So we tried to do magic over here. I guess we can also turn up the intensity in the magic recipe inside of CyberChef. We got depth of 3, and then what website are you using? Not CyberChef, but the other one. This one is called decode.fr. And it's a pretty well-known website for people who are enthusiastic about cryptography, especially classical ciphers. Okay, well, I don't see base 64 and then XOR hex. Whoa, what is this? Base 64 and then okay, so this is the flag. It looks like the flag, but what kind of encryption was this? So this is base 64 and then XOR hex string 3. So this is XOR byte encryption. Or XOR byte encryption. Let's give this a try. We'll see if this is the correct flag. If it's the correct flag, then the solution was base 64 into XOR encryption. Okay, let's go back to the challenge, paste in the flag, and that was the correct flag. Okay, so let's figure out exactly what was done with the ciphertext here. So according to CyberChef, it was base 64 decrypted, and then we need to apply something to this message. So I mean, this has something to do with the stuff we were doing before. It was let me grab the script that we're gonna be using today. So there's another script we were talking about that does XOR byte encryption. So it encrypts or it does XOR encryption with every available byte. Let's where is it? HackerFrogs. I think we've got this for CryptoHack favorite byte, this challenge here. So we're going to be using this same script, except we're going to be applying it with a different string. Okay, and let me just XOR brute. Sure. The only thing we need to do is we need to get rid of the string. So this is not a hex string. We're not feeding a hex string into this. Instead, we're going to be feeding in an ASCII string. So the ASCII string is going to be, where is it? This one. Whoops, got to copy the entire thing. Okay, so we'll just rename this from hex string to ASCII string. And we need to convert the ASCII string to bytes in this case. So data equals bytes from, I wonder if we can just do from ASCII. Convert ASCII string to bytes in Python. Need to look that up. Okay, Python convert ASCII to bytes. Actually, wait, I think this is bytes here if we do B in front. If we just type a B in front, this should count as a bytes object. And I guess we can just call this ASCII bytes. And in that case, we don't need to convert the ASCII string to bytes. And we'll just plug in ASCII bytes over here as the data. Okay, we'll see if this works. If it doesn't work, we're going to have to fix up our script a little bit. Whoops, we need to run Python on this. Python. Okay. Yeah, so we were able to brute force the message out by doing a XOR encryption or an XOR brute force with every possible byte from 0 to 255. So these ones actually produce a printable message. Any result that didn't result in a printable message, those are all going to be discarded. So this is where we get the flag. I guess we can go ahead and do our write-up then. All right, where are we? Here. So what do we need to know to finish this challenge? We need to know base 64 encoding, and then we needed to know XOR byte brute forcing. Okay, so we are given a string, a ciphertext string. There are... Okay, Kind of Geeky says, wait, we decoded from base 64 and then what? So, I'll explain it as I write as I do the write-up over here. So there are two layers of encryption, or two layers of transformation on this string. The first layer is a base 64 encoding. When we base 64 decode the ciphertexts, the resulting string is XOR encoded, or XOR, yeah, it is, it's XOR encoded. So the thing about XOR encoding is that you never know that something might be XOR encoding unless you were to actually do the brute force attack. So we can use an XOR brute force between the ciphertext and all possible bytes from 0 to 255 and get an answer. So how do we know it was XORed? We didn't know it was XORed initially, but we did put it through a tool. So the tool that we put it through was called CyberChef, and CyberChef has a certain type of mode that you can apply, which is called magic. And magic tries to do a bunch of different cryptographic operations on a piece of data to get a bunch of different possibilities. And then after it's done that, you can look through the possibilities to identify what might be the message. You have to do this manually, but in this case, we were able to identify that we found the flag because the flag is the word flag inside of it. But if we didn't know, then we could take a guess and then run the XOR encryption, or the XOR decryption in this case, using a Python script. So the Python script we use is this. But before I submit this, I should probably fix the script a little bit because it's a bit redundant. A couple of things that I need to fix up. It's Brody. Hello, nice to see you here. What is up with you? You know, we haven't done it in a bit. We just finished the challenge, so let's do this fun little video redeem.
What are you? I'm system root.
It's Brody. Hello, nice to see you here. And you said you made a game for streamers. I didn't know that you were a game dev. It's Brody. But what kind of game are you making? And if you have a GitHub repository or some sort of something that we can take a look at, maybe I can you can share the link with the stream. Thank you. Okay, what are we doing? Over here. Okay, we can use this XOR brute force. We can use this script. Can use this code. Okay, and I'll just paste in my Python code. and I just need to okay, so this is going to be the data over here. We don't need this line, and yeah, so this this should be okay. All right, we will commit those changes. We're done with this challenge. As Brody says, not really. I built it's an emote guesser with 7 TV emotes. Oh, interesting. Emote guesser. All right. So if anybody wants to try out the emote guesser that It's Brody created, there's the link. I'll paste in the chat again so that you can all try it out. All right, let's try another challenge. So this one was a little bit more challenging than the other ones for sure. Okay, some Martian message, part 3, and let's take a look at the new challenges. Okay, so let's do. So what we're doing here is we're trying to work through the challenges in order of difficulty. The easiest first, and then the more difficult ones later. So the way we're trying to keep track of what is difficult or more not difficult is the number of validations over here. So more validations means it's more people are able to complete the challenge, which means it's easier. So let's go ahead and do the next one. I lost my password. All right, let's give this one a go. All right, so this one is at this link here if you want to try it out. I guess I could also give everybody the link to the file that we need to download. So I'll just copy that link. There you go. And you might or might not be able to download this depending on whether or not it requires you to be logged in. If it does, then you're not going to be able to use that link. But let me download the link. Okay? And let's start our write-up. So what is the name of this challenge? It's called I Lost My Password, Can You Find It? Okay. This will be the name of the challenge. I'm just going to rename the file a little bit because I'm working inside of GitHub, and GitHub does not like certain special characters like spaces and the like. It also doesn't like many special characters. Okay, and 2, 3, we're going to record the URL for the challenge, and then the concept we need to understand, and then the method of solving the challenge. Okay, so where's my URL? It is here, 51. Okay, concept we don't know yet, and let's go ahead and move that zip file to our temporary directory here. Let's see, move from downloads. What is it called? Uh-oh. I've got a lot of stuff in my downloads directory. I gotta clean it out one of these days. Tab for more. Was this called Fishnet? Or was it called something else? Oh, this was called 32 something something. Okay, let's go ahead and look for that. 32.zip. Move it here. Okay, good. And let's unzip that file. Oh. Okay, well, this looks like something from a Windows machine. So something from a Windows machine, it's here, and the name of the challenge is I Forgot My Password. Can you find it? I lost my password, can you find it? Okay, so we're probably going to be looking for password hashes inside of the Windows, inside of the Windows files here. So where do we find those? Okay. There's probably some NTLM hashes in here somewhere. And you know what? Let me go ahead and copy all of these all of the files here. Well, not the files, but the names of the files. we're going to give it to our good friend ChatGPT, and maybe it can help us solve the challenge. So here, I'm going to say, I have a list of files for a CTF challenge. Which of these files likely has password hashes? Okay, paste in the entire list, and then we will see. So this is probably something I need to know for Windows hacking in general, because, well, every once in a while you will compromise a Windows machine, and then you can start looking inside of there. Among everything listed, one file stands out immediately, so this is groups.xml, okay? But why? So this file is notoriously known for storing plain text or reversible encrypted passwords in many Windows versions. Microsoft deprecated it because attackers could extract passwords from it. This is a classic CTF argument. Groups.xml. So let me locate that. So grep out groups.xml. Whoops, we're not, okay. What we need to do here is we need to use a certain command. That certain command is, well, we can use the word, yeah, it's find. So find in this directory something named groups.xml. What do you mean permission denied? Hold on. This is it right here. So, I mean, I guess I shouldn't have been getting fancy with it. Let's just take a look in this directory here, or in this file. Okay, so C password. Full name administrator, description administrator, C password, this. But is this... I don't think this is a plain text password. This is probably an encrypted password, so we should do some more investigation. Okay, and there's no other password stuff in here, right? Why groups.xml is the answer. The Windows group policy preferences feature allowed admins to set local users' local passwords, stored passwords encrypted with a publicly known AES 256 key. So when we go back to the challenge, it wants us to directly submit the flag. So we shouldn't stop investigating until we have an actual flag value. Okay, let's go back. So we found a potential password. Is this likely an encrypted string? So this is, oh, you know what this looks like? This looks like base64. So I mean, base64, it shows up a lot inside of what is it called? Inside of CTF challenges. So let me just grab this, and we'll try base64 decoding it really quick now. So echo out this thing, and then base64 decode it. Okay, so I mean, it looks like it might be a base64 string, but this doesn't decode to anything printable. Okay, so this is absolutely an encrypted password. It matches the exact format of a GPP, group policy preferences C password value, which is an AES encrypted with Microsoft's publicly known GPP key. Okay, so CTFs love using it, great. So this over here, it's a base64-like character set. All right, so I was able to identify that. Shows up specifically in groups.xml, enclosed in C password equals. So background, GPP encryption, Group policy preferences store passwords like this. So the encryption details are AES 256 CBC, static 4, static key, base64 encoded. Anyone can decrypt it. This is why Microsoft removed password support from GPP after this version. So maybe like 10 years ago. So how to decrypt it? Safe to explain. Top commonly used tools. So GPP decrypt from Python. We can also use PowerShell. We can also use the M platform. And we can also do manual decryption. So TLDR. Okay, so I mean, if we can use a well-known Python script to decrypt it, then why not? Let's see if, well, this might be a tool on Kali Linux. Yeah, it is a tool on Kali Linux. So we just need to provide it with the password string, and we'll see if it can get the job done. Local root. The password is local root. Let's try submitting this as the flag. If this is not the flag, then we need to find some other way to go about it. Yeah, we just solved it. Okay, great. Let's do our little write-up. So the concept we have to understand is Windows groups.xml file. And we also need to understand how to decrypt. What were these things called again? GPP passwords. So GPP encryption, I guess we could call it. How to decrypt GPP encrypted passwords. Okay. So let's talk about how we solved the challenge. So first we download the zip file, unzip the zip file, and then see that there is a groups.xml file included in the unzipped files. We should probably highlight this. So it's possible for encrypted passwords to be found in the groups.xml file. We can decrypt those encrypted passwords using a common tool. What is it called? Kind of geeky. Nice job. I'm impressed. Yeah, I mean, it was mostly Googling around or searching around and asking. But it's called GPP decrypt. So this is something that we should remember when we're investigating Windows servers. So if we're ever able to break into a Windows server and it's using like a very old version of Windows, then this kind of file might exist on the file system, and we could potentially get passwords from there. Okay, and let's just copy this. It's called GPP decrypt. We will supply the name of the actual command here, and then we're done. We might be able to do one more of these, but I'm getting the feeling that the difficulty level of these challenges is going to get much, much higher after this. But you know what? Let's go ahead and play a little bit of music while we solve what's probably going to be the last challenge for this section of the stream. Let's play some of this music. Okay, so what's the next challenge? The next challenge is, let's see, we've got so the challenge with the next largest number of solves is going to be 788 or 718. Let's do this one over here. Can you understand the sentence? Oh, interesting. Alright, so everybody, this is the encrypted string. We just need to figure out what's going on here. We'll start our write-up. Whoops, that's not it. So the name of the challenge is, can you understand this sentence? I'm just going to remove all the spaces in here because GitHub does not like spaces. We'll record all of our usual things here. So we're recording the URL where the challenge is, the concept we need to understand to solve the challenge, and the method of solving the challenge. Okay, so the first thing is the URL. So our URL is over here. And if anybody wants to try this out themselves, you can either grab the ciphertext over there and start playing around with it, or you can navigate to the challenge on RingZeroCTF. Okay, the concept here we don't know yet. And can you understand this sentence? Well, first of all, we can try to use some common tools, like the what was it called? The cipher identifier. So we'll analyze this. What does it say? So this is a multiplicative cipher or a monoalphabetic substitution, cipher disk or wheel. So these all look kind of like, they look kind of like alien words. I'm not sure what this might be. Music's a bit loud. Let me see if I can turn it down a bit. So multiplicative cipher, monoalphabetic substitution. Well, we can take a look at these things and see if this makes sense in this case. So multiplicative cipher. Let me grab that ciphertext again. Okay, and then decrypt without key. Yeah, because we don't know what the key might be. We get a bunch of results. None of these look like anything that makes sense to us. What's something else we could use? So it says this could also be monoalphabetic substitution. We can take a look at this. Paste in our ciphertext. Try to decrypt it automatically. This doesn't give us anything that we can use. The other thing we could do is we could try some Caesar cipher on this as well. So Caesar cipher. If this is some sort of Caesar cipher, then we should be able to see it after we brute force it. So brute forcing this doesn't seem to get us any results that we can understand. Nope. Okay. Let's multiplicative cipher here. Does this represent some sort of transformation? what was the puzzle name again? The puzzle name is Can You Understand This Sentence? Can you understand this sentence? Well, I mean, the thing is that these are all the same length. These are all five-letter words. And there's 1, 2, 3, 4, 5, 6. There's 7 of them. Let's try feeding this to ChatGPT. It might be able to help us identify something. Okay. Or you know what? We could also feed this into CyberChef, because CyberChef was able to get us the win last time. Okay, nothing of interest could be detected about the input data. Have you tried modifying the operation arguments? Okay, let's get rid of the magic, and then we'll apply the magic again. We get this stuff. We'll try intensive mode. See if it's able to get us anything interesting looking. Nope. Well, I mean, nothing that looks like anything. We could also try Googling something. So cipher with multiple words, each word the same length, the same number of letters. See if something pops up. The act of structuring a cipher into multiple words, each with the same number of letters, is a standard technique used to disguise the natural word boundaries and patterns of the original message, which aids in confusing frequency analysis. Columnar transposition ciphers. So often 5 letters, known as 5-letter groups. So, I mean, we've got 5 letters. Substitution ciphers. Ciphertext from substitution ciphers also commonly broken into equal length groups. Frequently 5 characters to hide common single letter words like A or I. Okay. So a shift cipher, so it says, we also get this result here, shift cipher. Cryptographic cipher where each letter in the plaintext is replaced by a letter a certain number of positions further down. I'll try feeding this into our good friend the AI. Maybe it can make sense of it. Where is that again? Here. Okay. We are doing more cryptography. This is the ciphertext. So let's see if it has any bright ideas. I spelled cryptography wrong. That's great. Hopefully that doesn't get in the way of a response from our good friend the AI. I mean, I could have sworn I've seen a cipher kind of like this before. So it's just like a group of words. Classical cipher techniques, substitution. These groups could map to single letters. So letter frequency analysis. This is something I don't do very much of, because I'm usually dealing with beginner level cryptography challenges. Okay, so So it's talking about all the possible options. I guess I could go off and talk about we can explore some other stuff for a bit. So it's CPAC, COMOC, RePuc, VANIC. So we see some repetition of words in here. Sorry, repetition of letters. Letters in certain spaces. It says there's a lot of K's at the, you know what, let's go ahead and go over here. I'm probably going to be working inside a bunch of different terminals later on in the stream. So I'm just going to start giving each one of these tabs a different color. And we'll be moving between the different tabs. Okay, so this one here, let's take a look at it inside of Nano. So these are the words. Let me put them all in a row so that we can do a little bit of an analysis. Okay, so there is a K in the last letter slot of each of these words. So these are some observations. And what else? So aside from that, is it always consonant, vowel, consonant, vowel, consonant? If we count the Y as a vowel, then it fills in this pattern. There is the pattern for each word is consonant, vowel, consonant, vowel, consonant. Kinda Geeky says reverse each word. Reverse each word? CPAC becomes Capix. Comoc becomes Comoc again. I guess we could do some playing around with this thing. We might have success reversing the strings. So if that's the case, then K-A-P-I-X, this becomes K-O-M-O-C, this is K-U-P-E-R, this is K-I-N-A-V, D-Y, whoops, it's K-U-T-Y-D, and K-Y-M-I-D. Last one is X-Y-N-I-S. No, I mean, everything could be a clue, so I'll take whatever, whatever suggestions come out, it's fine. I guess I should also put in the original string as well. What other patterns can we deduce from this? I'm not sure. Okay, let's see what the AI has to say. Okay, so it thought it was sitting there thinking for 2 minutes, huh? This is Bubble Babble encoding. Okay. Bubble Babble is a way of encoding binary hex into fake words like this to make them easier to read or speak. It's used, for example, in SSH key fingerprints. Okay, is this true? If you decode that Bubble Babble, you get Hacking Bubble. How to decode it for yourself? Hacking Bubble. So, I mean, is this Is this the flag? If this is the flag, then yeah, okay, that was the flag. So this is whatever this thing is, hacking bubble babble. Let's read more about it. So how to decode it yourself, Linux-ish approach. If you grab a bubble babble decoder, for example from PHP script, from the common online implementations, you can do echo this out and then run bubble babble on it, and it'll output this. In a CTF, the decoded value hacking bubble is usually either the flag itself or a key password to use in the next step. So I'd like to know a little bit more about this bubble babble encryption. Actually, this might be in Wikipedia. We can probably try looking it up. Okay, bubble babble. Cipher. Bubble babble cipher. This doesn't exist. Okay, so it's not documented in Wikipedia. Mr. Coding Beast says, new here, what is this? So we're just doing some cybersecurity exercises. We're currently doing cryptography, and we're going to be talking about cryptography for the next hour or so, and then we're going to be moving on into some Linux stuff. So if you want to learn about, if you want to try out some Linux puzzles, we're going to be working on over at this website a little bit later. So you might want to try some of these. They're pretty fun. They require you to do a lot of different stuff inside of the Linux console. But for right now, we're trying to figure out this kind of obscure cryptography system called Bubble Babble. Bubble Babble. Actually, wait. I wonder if it's here. So decode has a bunch of different stuff. Bubble Babble. Bubble Babble code. Word bubble solver. Bubble Babble code. So Bubble Babble code, ciphertext is here. Bubble Babble encoder, they've got a decoder here as well. I'm kind of disappointed that it wasn't able to identify it, but if this works, and I can just use like a web app to do this, that's pretty cool. Still don't understand how it works, but fine. It has a decode side though. Yeah, oh, okay. But yeah, thank you very much, Mr. Coding Beast. And V Daniel, hey, what is up? What is up? Alright, let's grab that original ciphertext. So the ciphertext is here, and then we'll decode, and then we get hacking bubble. But how does this actually work? Bubble Babble code. Let's just do a search. Encoding algorithm. I mean, we're looking for... we get bubble bobble instead. So, there's not very much on the internet talking about this. Bubble babble encoder. Well, I mean, we got a GitHub repository here talking about it. Okay, bubble babble encoding for Node.js. Yeah, okay. So I guess this stuff looks very, very similar. I kind of want to know how it works though. All right, we'll try asking the AI in this case. Actually, well, is there a good online resource for learning about Bubble Babble code? Bubble Bubble Gum. Try typing bobble on Google. Google? I didn't get anything. Or filter bobble. Oh, okay, filter bobble. When we're doing our search in Google, of course. Okay, there's several solid online resources if you want to learn about bubble babble encoding. Here are a few of the first one. Original specification. In-depth technical write-up. A more approachable explanation with example. And there's the decode page. So we know about the decode page. It doesn't say anything about... What is bubble babble definition? So this is what we want. Is an encoding format invented to represent digital data as pseudo words that are easy to read, pronounce, and remember. Each encoded string represents a sequence of syllables that don't correspond to real words but are easy to read, dictate, and verify. Okay? So I guess this is what we're looking at. Encoding with bubble babble involves transforming binary data into a sequence of syllables to form short pseudo words, split into 2-byte blocks. If the length is odd, add a null byte. Transform each block into 5 letters using a bit shift in modulo mechanism. Okay, so this is the pattern, yeah, so it is vowel, consonant, vowel. Okay. So how to decrypt? I mean, we can use the tool to decrypt this thing. Anyways, let's start documenting this, and then we can move on to the next part of the stream. Okay, so this is the bubble babble. Bubble babble code. Method of solve. So we are given a series of words, and I guess we can actually provide the series of words in this case. This turns out to be bubble babble code. We can learn more about it here. We will provide the decode article over here. Where is it? Here. Okay, there's the website where we can learn more about it. But we can ID a bubble babble encoded. I guess this is a method of encoding. This isn't really a cipher because it's meant to be used in some sort of practical application. So it's a bubble babble encoded string. Anytime you see this kind of thing, then it might be the clue that it's encoded using this bubble babble method. An idea bubble babble string that is a series of nonsense words that are all the same length. Okay, and we can use this tool to decode the message. Okay, and we'll just give a link to the decode page again. Okay, copy, and then paste it in. We're done. Kind of geeky this. Think of it like Base 64 that tried to sound like a cute robot language per ChatGPT. Is that what ChatGPT said? This is, I mean, the cool thing is that we're learning new stuff. I never knew about this Bubble Babble thing. Apparently it's a thing. I didn't know, but the next time we see something that looks like this, then we'll know that it's supposed to be Bubble Babble, or maybe it won't be. Okay, let's move on to the next topic. So we're going to be doing another 60 minutes on our next topic. Topic 1 is done. Topic 2 is here. Topic 3 is on deck. And we're doing HackerFrogs AfterSchool. Let me turn off the music and let's get started with our cryptography workshop. So this is going to be our last cryptography workshop. And all of the links we're going to be using can be located over here on the GitHub. It's understandable. It's understandable. I mean, we're trying to understand. We're trying to learn new stuff. George McDonnelly says, "Are you creating an education website with the title Bubble Bubble Bubble? Not Bubble Bubble. something kind of close. All right, so let's go ahead and start the lesson. All right, everybody, this is HackerFrogs AfterSchool Cryptography Basics 5. So this is the last cryptography session we're going to be doing for HackerFrogs AfterSchool. If you're interested in learning about network hacking stuff, we're going to be starting that next stream, but this is the last one for cryptography. Welcome to HackerFrogs AfterSchool. Hey there, HackerFrogs. This workshop is the 5th session for Cryptography Basics. In the last session, we learned about the following cryptography concepts. Never heard of either? It'll be easy to recognize in the future. It is pretty distinct, yeah, for sure. So the XOR operation. The XOR is a bitwise operator which can be performed between 2 or more numbers and returns the number 0 if the bits are the same and 1 if they are different. So we've got a bunch of different properties as far as the XOR operation is concerned. So there's this commutative property, which means that the order in which you put the two numbers before you XOR them, that is not going to affect the operation. Associative means that if you have 3 numbers that have been that are the result of the XOR operation, if you have any 2 of them, you can find the third one. So if you have A and B, you can get C. If you have C and A, you can get B, etc., etc. So the identitive feature of XOR means that if you XOR any number by 0, you get the same number. And if you XOR any number by itself, you get 0. In today's topics, we're going to be doing our warm-up exercise, and then we're going to be solving some XOR with partial info. We're going to be doing some puzzles, and we're going to be learning about the OTP cipher. The OTP cipher is a cryptographic cipher that uses XOR concepts. So we're going to do a warm-up exercise. Let's reacquaint ourselves with the XOR operation by solving the following challenge over at the CTF Learn website. So CTF Learn is another one of these CTF platforms. I've got quite a number of these that I've got ready to go at any one time. And you can find it over here at ctflearn.com. If you don't have an account over there, I think I can give you about as much information as you need to solve this challenge. And before we go on, let me go ahead and close out some of these browser tabs that we don't need, because we've got quite a few of them. And it always feels a little bit uncomfortable when I've got too many of these browser tabs open. This is done. Okay, so let's see. So the CTF Learn link is over here. If you're logged into CTF Learn, you can access the challenge from this link here. Thank you very much for following Your Crack. Thank you. What is up? What is up, Your Crack? Nice to see you here. Let's give you a fun video redeem. How about some Jurassic Park?
all the files of the whole park. It tells you everything.
George McDonnelly says, "Where's the first session? How can I watch it?" Yeah. So if you want to watch the previous session, Lore Crack with the L. Oh, sorry, I didn't recognize that was a lowercase l. Where's the first session? Yeah, you can go back to the previous live stream and you can go to the second hour. So we do the educational portion during the second hour of each live stream. So just go to the previous one that was on Friday and then go to the second hour and you can find the recording there. Okay, so it looks like CTF Learn is not being very responsive right now. Let me try putting this in another window. If this doesn't work, then we're gonna have to find another warm-up challenge. I guess in the meantime, we can just talk about what the actual XOR challenge is, or what the actual XOR operation is. So the XOR operation, it's a bitwise operation. If you've got a binary number, like this, for example, and you've got another binary number of the same length, whoops, let's do I have no idea what these numbers are, but I guess we could translate them if we wanted to. Okay, and if we do the XOR operation between these, what we do is we line up each one of these numbers in the columns. If they're not the same, so 1 and 0 or 0 and 1, then we put a 1 as the result. Okay, if the numbers are the same, so 0 and 0 or 1 and 1, then we have to put 0 as the result. Same thing here, okay. Same, different, same, different, same, different. Okay, so the interesting thing about this operation is that we can reverse it. So if we do this operation here, which is the XOR of these two numbers, and we've got any one of these numbers as well. So let's say we got this one, and then we do another XOR operation between this number and this number. Okay, let's label these because, you know, so this is A, this is B, and the result is C. So if we have C and we have A, then we can get B. So we just, let's see, so this is B. So we just do the same thing, the same operation. So it's same, different, 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 same. Okay, so this should be equal to the value for B. It looks like, yeah, this is the same number here. So we can also treat this as cryptography, because if we've got A, the ciphertext here, and we've got B, the secret key, or the XOR key, XOR key in this case, we can get C, the ciphertext. And if we've got the ciphertext and we've got the plain text, then we can get the key. Or if we've got the ciphertext and we've got the key, then we can get the plain text. 158, is that what it is? I mean, I wasn't really paying attention. Okay, so did we manage to get our challenge? We didn't manage to get our challenge. So I guess we might have to skip it. But the other thing, well, I mean, we can also do like a recap of what we learned last time. So we can also do XOR operations between ASCII characters. So if you have an ASCII character, say we've got the word label, and we do the XOR operation with the number 13, then we can get a new set of ASCII characters after we do the XOR operation between each one of these letters and the number 13. And in this case, we were able to get the word aloha, like this. So same thing would apply. So if we were to take the word aloha and then XOR it with the number 13, we would get back our original message, which is the word label. But okay, so we're just gonna, looks like yeah, we're not gonna be able to do CTF learn. So we'll move on to the next thing. Okay, solving XOR with partial data. So this is the next thing we're gonna be learning about. So suppose we have 3 values in a CTF challenge. We've got A, the plain text, B, the key, and C, the ciphertext. So in our example here, our plain text is the word secret. Our key is this series of letters and numbers, and the ciphertext becomes this. If you run an XOR operation between this letter and this letter, you get the capital D, and then if you run it between the letter E and the letter K, you get the period over here. Same thing with the other letters. If we've got the ciphertext, we could potentially get back the plain text if we were to capture the key value here. Okay, George McDonnelly says, what you type in the terminal for? What I was typing in the terminal over here. So I was trying to illustrate how we could do operations, XOR operations between ASCII characters. So when you want to do an XOR operation between an ASCII character or another value, every time you want to do that XOR operation, you need to convert everything to binary numbers first. So of course, anytime you've got an ASCII character, so ASCII character capital A, it could be interpreted as the number hex 41, or it could also be interpreted as the decimal number 65. So in this case, the decimal number 65 can also be converted into binary. So there are a bunch of different tools we can use for this. So decimal to binary. Of course, it's possible to do the math yourself, but I am not here to do that. So the number 41 is equal to this number in binary. And so if you want to do XOR operations between ASCII characters, you first need to convert the character into its binary equivalent, and then you would have to find the equivalent for whatever you wanted to do the XOR operation between. Okay, so let's go back. So if we have C, the ciphertext, we can guess, and we can guess at the part of the value of A. We can get partial insight to the value of B, especially if the length of B is shorter than A. So if we have an XOR, say we have our secret word secret, and it was encrypted with, we don't know what the key is. And then the result would be ciphertext. So we got our A, our A, our B, which is the key, and our C, which is the ciphertext. If we know that the plain text, if we can guess at what the value of the plain text might be, then we might be able to get a partial match by running the ciphertext and doing the XOR operation between that and what we think might be part of the plain text, which was used to XOR operation at. Let's go over to a challenge to talk more about this. So crypto hack. So the challenge is called Either You Know It, XOR You Don't. So we're going to learn about this concept of XOR by doing this challenge over here. If you don't have an account over at cryptohack.org, you can make one for free. Let's go ahead and go to that website. Where is it? Here? Okay. Okay, so this challenge from CryptoHack is called Either You Know, X or You Don't. I've encrypted the flag with my secret key. You'll never be able to guess it. So remember the flag format and how it might help you in this challenge. So the thing we need to understand about this challenge is that all of the CryptoHack keys look like this. So CryptoHack flag format. So inside of CTF challenges, the flags, or the things that we need to get from the challenge to submit as to prove that we solved the challenge, they usually solve a certain format. So in CryptoHack, it's the word crypto and then the flag contents between some curly braces over here. So this is pretty typical of CTF challenges. In other CTF challenges, you might have Pico CTF and then Pico flag contents in between the curly braces here. So if we know that something has been XORed and we know what part of the plaintext is supposed to look like, we may be able to get part of the key that was used to encrypt it. George McNally says, I've created mind. I see this work as a point somewhere in space. A point somewhere in space? Well, I don't know. I don't know about that, but, well, we can certainly learn about some cryptography stuff right now. Okay, so what does the challenge let us know? I've encrypted the flag with my secret key. You'll never be able to guess it. So remember the flag format might help you with the challenge. So we've got this value right here. If you want to give this a try yourself, this is the hexadecimal string that we need to decrypt. So let's take a look. Let's use another. So I'll call this script XOR partial. And the first thing is we need to include some Python libraries. Some from the Pwn tools. We're going to import all the stuff. Oops, all the stuff over here. This feels a bit like how they decoded the Enigma. I should probably look into that. I should probably look into the Enigma machine one of these days. Okay, so what are we going to... This is the encrypted hex. So the encrypted hex string is this right here. What we need to do is we need to do an XOR operation between the encrypted hex and what we know is supposed to be the plain text. So partial plain text. That's going to be this right here, crypto, because we know that all the flags start with the word crypto. Mr. Garden Bee says, struggle kitchen grid mobile by using a partial decoding, that is. Yeah, that kind of. I guess it is a little bit similar at least. Okay, so let me take a look at what the script is actually supposed to look like. I solved these challenges maybe like a year ago, but everything that we're looking at today is inside of this GitHub link. Okay, so this is the code I've got. I'll explain what the code does, and then we can run the script. Let's get rid of this stuff. So it's not a very long script, but it is making use of some libraries instead of Python. So we got the encrypted bytes, and the reason why we need to get encrypted bytes is that when we use the XOR operation inside of the Pwn tools module, it only takes in bytes. So in this case, we've got two sets of bytes. So the encrypted bytes is the original message, which is decoded from hexadecimal. So bytes from hex, the original hex bytes, the original hex string rather. And then for the key bytes, we get what we know about the plaintext, which is the word crypto, and then this opening bracket here. So what we're going to do is we're going to do the XOR operation between the known encrypted bytes and the partial key bytes here. And we're just going to print that out by running the XOR function between these two sets of bytes, and then we're going to decode that into printable characters. Okay? Drunken Alcoholic says they worked out. The Germans always finish the message with, oh, okay. So that was that was known plain text. Knowing some partial text, they could decrypt part of the message. That's pretty cool. Okay, so let's run the script. So XOR partial. Okay, so we see that most of the message is garbled. Most of the message is garbled, but we do see something that is decipherable. So we see my XOR key. My XOR key, but they've got the plus sign in here. We can just kind of ignore the plus sign if we want to make sense of this. The reason why my XOR key is leaked out here is because we're each one of these each portion of the message is being XOR operated with this same key right here. And the thing is that when you're using the XOR operation and the key is too short, then the key will repeat over and over again to fit the length of the message. So this is what we're going to do. We're going to go back into the Python script. And instead of key bytes, we're just going to call this, well, this is still key bytes. Instead of crypto, we'll put in my XOR key. So the thing about this is that let's pretend, right? Let's pretend that we've got our plain text message. But if we pretend that the key is just my XOR key, my XOR key, then this is going to repeat over and over again. This will repeat twice because it should be, to be secure, if you want to use XOR as an encryption method, you have to make sure that the length of the key and the length of the message match. If the key is too short, then you're going to run into problems where if people can get if people have an idea about the part of the value of the plaintext, then you're going to be able to get the part of the value of the key. So ciphertext message. Okay, so here we've substituted in the actual key instead of the partial plaintext, and we're just going to do this again. What we should get here is we should get the entirety of the plaintext. Okay, so let's run Python again, and we get the entire flag. Crypto, if you know it, if you know enough, you know it all. So this is the flag for the challenge. Go back into here, into CryptoHack, and then you can submit the flag. So I don't get to submit the flag because I've already submitted the flag. But that's how you do it. See, talking about partial text to decrypt. So somebody mentioned the Enigma. Yeah, that's right. But this is something we need to remember when we're talking about the XOR, about XOR. So if you're using XOR as an encryption method, we could probably do this ourselves. So let's just pretend that we've got a secret message we want to encrypt. HackerFrogs, like and subscribe. And then let's pretend that we want to XOR this with a key. And let's pretend the key that it is really short. Let's just suppose that we're encrypting it with the word key. Okay, and what we would do, because the key is shorter than the length of the message, we need to repeat the key over and over again until it matches the length of the message. So key, 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 like this. Okay, so if we're following the same kind of theory that we did for the previous challenge, this is what we would do. So HackerFrogs like and subscribe is our plaintext message. Copy that. Let's go over here. Python. Let's see. XOR partial. Ooh. Oh, okay. Okay, so this is what we're looking at here. So encrypted bytes equals not this. Actually, we're not going to call this encrypted bytes. This is going to be plain text. Plain text bytes. Okay, and it's going to be this. And we're going to make this bytes by putting the B in front of the string. And the key bytes, it's just going to be the word key. Okay, and then we're going to encrypt the plain text bytes and the key in the key bytes. Plain text. Okay, so if we do this, we're going to get an encrypted message. Maybe we should be interpreting this as as hexadecimal, because this is probably not going to produce anything that we can print out, but let's just give it a try. Okay, we just get these bytes over here. So if we've got these bytes over here, and we know that part of the message is like HackerFrogs, or we know that the word HackerFrogs is in here, then we could probably do the same thing, the same sort of attack. Mr. Pro says, about to start the career of cybersecurity from a different career that has nothing to do with tech. I liked pen testing, but I'm good with working at SOC or something similar to gain experience. Are you looking for like a job that you can aim towards? For people who come from a background that is completely divorced from tech, I've got a starter pack over here. So this is a series of different YouTube playlists. So the first two playlists are for people to get familiar with tech in general. The third link is for learning computer networking, and the fourth link is for doing some easy cybersecurity challenges to get used to solving cybersecurity challenges, basically. But yeah, all the best luck to you, Mr. Pro 34. Okay, so let's move on to the next challenge. So the OTP cipher. So this is a encryption method that is very similar in theory to the XOR operation. The OTP cipher is an encryption technique that requires a plain text and a secret key. So we got plain text A, key B, and we get the ciphertext C. So the OTP cipher usually uses like some sort of what is the word? A chart. So OTP cipher chart. The one-time pad. Let's see if we can get something like this. Plain text key over here. Let me see if I can. So we can use something like this to do the encryption. Let's see, open image in new tab. Okay, here we go. Okay, so what you would do is you would map out the plain text and the key to do the OTP cipher. And let me demonstrate that. So let's just pretend we've got our plain text. So our plain text, we've got our key and our ciphertext. Ellie Hamza, hello, nice to see you here. What is up? How are you doing? Doing all right? Vigonaire site encryption is a good OTP type cipher, or Caesar is another type of simple encryption. Yeah, for sure, for sure. We've been talking about those encryption methods, Drunken Alcoholic. Okay, so ciphertext, plaintext key. Let's pretend that we've got our plaintext, and it is just the word hacker. So if the plaintext is the word hacker, and the key is, let's pretend the key is secret, then our ciphertext would be something. What we need to do is we need to match up each one of the letters in the plaintext with each one of the letters in the key, and then encrypt them one by one. Okay, Ali Hamza says, what is the main language to learn to do hacking and stuff? To do hacking and stuff? I mean, you could do hacking with any number of different languages. A lot of people begin with the Python language. And the reason people start with the Python language is because it's very, very popular, and you can get started with it pretty easily. Let me get you some education links. Okay, so we've got a number of education links over at the HackerFrogs GitHub over here. And let me just get you the one for programming. You can take a look over here. From this page, I highly recommend these two courses for learning Python. So these are two very, very in-depth courses. They represent 70 hours of material. By the time you finish them, you should have a pretty good understanding of Python and how to code with it. I've taken the first course myself. It was really, really good. But let's continue on. Okay, so encryption requires that each letter of the plaintext to be combined with its corresponding secret key letter through modular addition. So if we do plaintext secret, key is hacker, then we get this ciphertext over here. So OTP cipher has some similar rules to XOR operations, since A XOR B equals C and C XOR B equals A, etc., etc. So what we're going to do next is we're going to solve a challenge from the PicoCTF platform called Easy 1. So we're going to be learning about OTP cipher by working through a challenge on PicoCTF. Let me get the links for everybody. Not this. This. Okay, PicoCTF Easy 1. This is the link. You can sign up for PicoCTF as well. It might seem like a pain in the butt to sign up for all these different services. Each service has different challenges and different uses. PicoCTF is one of the best. Okay, let's go ahead and navigate over there. After you've logged into PicoCTF, you can go to the link, and we see over here there's this challenge called Easy 1. It says the one-time pad can be cryptographically secure, but not when you know the key. Can you solve this? We've given you the encrypted flag, the key, and a table to help. So this is the encrypted message here, and this is the key. Can you use this table to solve it? Okay, so let me give everybody. Glad to see that your GitHub is back. Yeah, for some reason. For some reason, my GitHub got locked. So this is the ciphertext for the challenge. The key is solve crypto. And they give us a table here. I'll give everybody a link to the table as well. You should be able to download it even if you're not logged in. Actually, let me wget this thing. Okay, so this is the lookup table here. So this looks, I mean, it looks very similar to the Vigenère cipher. Let's see. So what is the ciphertext again? It's UFJKXQZQUNB, and the key is solve crypto. Okay, so in this case, the length of the ciphertext and the length of the key is the same length. So this makes it secure. So what we need to do is we need to solve the plain text for this. So we got U and we got S. So what we need to do is I think we need to locate S down here. And then we need to find U. Or wait, we find, where is it? U is here. Where is it? George McDonnelly says, can you tell me the first letter of my name? I'll create another name. I'm sorry, what? I'm not too sure what you're looking for in this case. So let's see. We got this here. We got solve crypto. And I think what we need to do is so it's either take this and then go down until you find the first letter of the key and then go over. So you go down until you find, the letter S isn't here though. Let's see, or maybe this is the key. So S, go down until you find the letter U, and we have the letter C. If you do that the same way with the letter F, anyways, sure, it's not using both the columns and the rows, not the columns and the rows. Scroll down maybe. Oh, you're right. You're right. Oh, you're right. It's too big on the. Yeah. It's too big on the. I need to fit the entire thing on here. Okay, so now I can see it. Okay. So normally on this kind of lookup table, you would go to the key would be on this side over here, the left-hand side. You find the first letter, and then you go across until you find the plain text letter. In this case, it's U. Then you go up, and that's the letter C. Okay, second one, the letter O. Go across, find the letter F here, and then go up. Sorry, where's the letter F? O. Find the letter F, go up, and that's R. Next one is, let's see, it's L and J. So L, J is here, go up, it's Y. So it looks like the word crypto is something. V and K, so V, K, go up, P. Well, I'm guessing it's going to be crypto something. So crypto, and then R. Go over until you hit the letter Z, then go up, I, and then Y and Q. Y, Q is S, and then P. Oh, okay. I think I remember this one. So what you get is crypto is fun. So crypto is fun is the message, and what we need to do is we need to wrap this in the PicoCTF wrapper. So the PicoCTF wrapper is, it looks like this, PicoCTF, and then the message is between the curly brackets. So this would be the flag. We can submit this. Jason IT Solution says, what challenge is this? It's the easy one challenge over at PicoCTF. This over here. Okay, and let's go ahead and submit this flag, just so we know that this is the actual answer. Okay, that was the actual answer. So another way we can solve this, let's take a look at the GitHub. So submit the flag. PicoCTF crypto is fun. We could probably do. We can use like an automated app as well. So we could use this one. Okay. It's a weird way to look up a table. Nice, I learned something new about lookup tables. It's definitely something you need to learn. Okay, so one-time pad, we're going to be doing decryption, and they give us the information here. So this is the ciphertext. We'll just paste in the ciphertext here, and then the encryption key. So the encryption key is solve crypto, and we get the result crypto is fun. We can also you can use a few different websites to achieve the same thing. Okay, let's see. But for what? The DEC message, the decipher, the decrypted message. George McDonnell asks, what should it be used for? What should it be used for? I mean, we could use this to encrypt a message. So the thing about, I mean, the OTP system is actually secure. It's secure if nobody knows the key, and if the key is like random gibberish. If you make the key something that people can guess, then it's not secure. So let's just pretend like we want to encrypt something using OTP. So OTP stands for one-time pad encryption. And when we use the one-time pad, let's just suppose we got some plain text. Plain text equals HackerFrogs like and subscribe. Okay, and we have to produce a key that is at least, if we want it to be secure, we have to produce a key that is at least as long as the plain text in number of characters. So key could be some gibberish. We just need to make sure that it's the same length as the ciphertext. So we could use an application to do this, like this one over here. We can do some encryption. We can give an encryption key. So let's try this out ourselves. So HackerFrogs like and subscribe is the plain text. So every lookup row table is row and column. So this is new to me. I think you might be able to do it. You might be able to do it with row and column as well. I'm not really sure. I haven't tried it myself. RK, hello, nice to see you here, and thank you very much for subscribing on YouTube. Okay, let's give this a try. So here, our plain text, HackerFrogs like and subscribe, and we need to give the encryption key. So if the encryption key is something random like this. I mean, this isn't completely random, but it's about as random as I can do. Okay, and then we get this result over here. They truncated, unfortunately, but it should be about as long as the ciphertext. So the ciphertext and the plain text is going to be the same number of characters. Let's just do HackerFrogs like and sub, and we get this over here. So if we know the length of the key, if we know the key and we know the ciphertext, then we can decode this. Let me just, that looks about, yeah. Okay, let's go ahead and do the last part of today's stream. Last part of today's stream is not the last part of today's stream, but the last part of this section. The summary. We're doing the summary already, geez. George McConnelly says, my brain perceives this all as an abstraction. So, I mean, you could not perceive this as an abstraction if you do this yourself. You can go ahead and try over on this website to use the one-time pad. We could also do it manually. Let's just suppose that we just want to do plain text HackerFrogs and then we use like a random key. So one-time pad, HackerFrogs is the plain text. The key, let's keep it as just a blob of ASCII characters. So the ciphertext would be, well, we'll just do the operation for the first 4 characters because I don't want to make this too long. So H and K. So we just go to the lookup table. Where's the lookup table? Here. H, and we go down to the letter K. Or no. We find the intersection between H and K. So H over here, and then K. So the intersection between H and K in this case is the letter R. So that's the first letter. And then we find the intersection between A and K. So A and K is K. A and K is K. Okay, great. Okay, and then C and L. So the intersection between C and L is the letter N, etc., etc. Okay, let's go ahead and we'll do our little summary, and then we can finish out. We might have time to do one more XOR related challenge before we move on to the next topic. So in this topic, we talked about solving XOR with partial data. If you've got the ciphertext C and you can guess at part of the value of A, then you can get partial insight to the value of B, especially if the length of B is shorter than A. So this is a way for us to break the cipher if we know part of the plain text. We learned about the OTP cipher. The OTP cipher has some similar rules to the XOR operation. Since A XOR B equals C and C XOR B equals A, etc., etc. Okay, so originally we were going to be talking a little bit about the about an overview of the RSA cryptography system, but we're going to be cutting ourselves a bit short because I did a little bit of a boo-boo with the what is it called? With the scheduling for the cryptography course. So we're going to be moving on to the next course in the next stream session, which is going to be about network hacking stuff. Okay, so let's do one more. Let's do one more challenge that involves XOR operations. I wonder if this site is back yet. We're taking a look at CTF Learn. The thing what I don't like about CTF Learn is that the website is not very responsive. So I guess we're not going to be maybe we shouldn't be making use of it in oh wait, it responded. Okay. Yeah, okay. So CTF Learn, it's here for now. So CTF Learn, they've got a bunch of challenges, and the one that we had to skip because it wasn't responding was this one over here. It's called Hextraordinary. Hextraordinary. Here's the link. Okay. So it says meet Roxy. Fresh Films has just subscribed with Prime. Thank you very much for subscribing with Amazon Prime, Fresh Films. So if you're on Twitch and you have an Amazon Prime account, you can give yourself a free subscription to any streamer you want on Twitch, which includes me. And I get $2.50 of your subscription. And yeah, thank you very much, Fresh Films. Okay, let's talk about this challenge here. So it says, meet Roxy, a coder obsessed with being exclusively the world's best hacker. She specializes in short, cryptic, hard-to-decipher codes. The below hex values, for example, she did something with them to generate a secret code. Can you figure out what? Your answer should start with 0x. So these are the two values that need to be XORed together. So we could probably get this done pretty easily. We'll take a look at what's going on. Okay, we got two values in the challenge, and these represent hexadecimal numbers. So if these are hexadecimal numbers, we would need to convert these to binary first. So hex C4115 and hex 4CF8. What we can do is we can convert them with any old application. We could also do it manually, but I don't. My brain doesn't work like that. So we can do hex to binary. And hex to binary converter, we got it over here. Thank you very much for subscribing on YouTube. TC and Musy. And Mr. Boston, thank you very much for the follow on Twitch. Thank you very much. Okay, so hexadecimal numbers. So put that in. We would get rid of the 0x. So the 0x is to let us know that this is a hexadecimal number and not a decimal number. So we can convert hex numbers here to binary, and this is the number here. I think we might be able to do this. We could do this manually. Okay, so if we know that this value here is this binary number, and let me copy that one more time. Because if we want to do it manually, we can just, and this one over here is another hexadecimal number, 4CF8. And we want to convert that to binary as well. And we get this binary number. Just copy that. So anytime you've got like one binary number that's shorter than the other one, and you want to do an XOR operation between them, you just pad out the shorter number with the number of zeros in the front, and then you can do the XOR operation. Not the same length, right? But we've got something we can do about that. Histario, thank you very much for subscribing on YouTube. So let's go ahead and do the operation. It's not super difficult. Remember, everybody, XOR, if the two number in the columns are different, it's a 1. If they're the same, then it's a 0. So this is different, same, different, same, different, same, different, same, different, same, different. Okay. So this is the number. Let me double check that number, because I just want to double check my work. Okay, one more time. Different, same, different, same, different, same, different, same, different. Okay, we got the same number, So what we need to do is we need to submit this number as a hexadecimal number. So let's see, GG Quack says, isn't there an XOR function in Python? There is. Yeah, so we could totally do this in Python as well if we wanted to. So let me grab these two numbers and let's see, get out of here. What should we call this script? We'll just call this XOR thing.py. And if we got some binary numbers, so binary 1 and binary 2, and we're going to run the operation between these two. So binary 1 is an integer, and binary 2 is an integer. Actually, the XOR operation should work between, well, I mean, we've already got these binary numbers. So they're both integers, and they're both in base 2. So this is how we would convert these from a string to a binary number in Python. Let me grab that first one. Then the second one is over here. Okay, and the XOR operation is going to be binary 1 XORed, which is this, with binary 2. And then print out XOR op. Let's see if this works. I like that you're doing the manual way. It really highlights out how XOR works. So import XOR. We only need to import the XOR function from Pwn Tools if we're doing some complicated stuff like doing XOR between XORing strings together and stuff like that, like long strings. If we're just doing like single numbers against each other, we don't need to use the more complicated module. So just Python XOR thing, we get this number. So this number is the decimal version. So if we take a look at our manually XORed number and we plug this into like binary to decimal, we should see the same result. So let's see, we'll do binary to decimal, enter binary number, convert. So this is 789997. So we get the same result over here, 789997. We just need to convert this to hexadecimal because the challenge over here, where is it? It says that the answer should start with the 0x, which implies hexadecimal base. So let's convert this to, oh, the hexadecimal number is coded. Awesome. Yeah. Okay, so the flag value that we have to give is this right here. Okay, so let's go ahead and submit that. Where is it? Challenge. So submit the flag. This is green because I already solved this flange before. You can't solve this twice. So, but this is what we would do. You just, paste in your flag and click on submit, and then you'll solve the challenge. Great. All right, let's move on to the next portion of today's stream. So the next portion of today's stream, we're going to be doing some Linux stuff. So topic 2 is done, topic 3 is here, topic 4 is on deck. Okay, we're going to be working on this website right here. It's called CmdChallenge.com. Sup, hello, sup, sick in the mind. Hello, nice to see you here. Okay, so we're just going to be doing this for the next hour. We might or might not use the entire hour, but what is this website? This website is a website where you need to use your cool mastery of the Linux command line to do certain things. And today we're going to be doing this first challenge here. We need to use a command command to print the 25th line of the file faces.txt. So we got our terminal over here. we can do any command we want. It'll show us the output down here at the bottom. And yeah, so we're going to be solving a bunch of little mini puzzles inside of Linux for the next hour or so. But before we start, let me go ahead and put on some music. How about this stuff? Okay, so if anybody wants to know, if anybody wants this challenge in particular, okay, Mr. Coding Beast says catfaces.txt tail -25 or tail 25. I mean, that's probably gonna get the that's 25. Yeah, that's 25 line. We want only the line 25. So we want something like the 25th line. So sed n 25p for faces.txt. Let's give it a shot. So Sick in the Mind is a Sick in the Mind. You work as a pen tester, right? You do network pen testing and web app pen testing stuff. Okay, so said. Oh, you're pen testing while you're watching the stream. No worries. 25 years of IT before pen testing. That's a typical route. You would move from another. You'd move from another role inside of IT into cybersecurity. So let's see. Said n 25p. So 25p is the 25th line in this case for faces.txt. That works. Okay. So we get to look at the next challenge. Currently pen testing. Oh, your current career is pen testing. You're not working right now. Although I suppose, you know, your boss wouldn't mind if you were watching live streams as long as you're getting your job done. That's what I assume. Okay, so the next challenge is this. Print the lines of the file reverseme.txt in this directory in reverse order, so that the last line is printed first and the first line is printed last. Okay, so it looks like this is the contents of the file, but you know, okay, so this is reverseme.txt. Let's just read it out. Yeah, so it's exactly this stuff right here. We need to print out these things in opposite order. So is it something like rev? That's a cool website. Need to bookmark this one. Second line says, I was previously a Red Hat certified admin and Microsoft certified IT professional when that was a cert before they went back to the MCSA, MCSE model. Yeah, I mean, there's a lot of people working in cybersecurity who are previous systems administrators. Okay, so we need to print this out the lines out backwards. Typically, what I would do in this case, I would just look it up. So print lines in file in reverse order. Okay, you can use tack. There's a so there. Oh, all right. So there's a command inside of Linux to cat out things in reverse line order. Really? Okay. Well, I mean, we also have like a testing environment in our Kali Linux here. So let's just say we've got table.txt and it looks like this, but we would want to use. Oh, cool. Yeah, it seems to work. So we're getting I've never had to do this before, of course. Didn't know about that. TAC must be new. I mean, I wonder how new it is. So it doesn't tell you when this thing was created. But it's the opposite of cat. Well, I guess it's not really the opposite of cat, but it's cat in reverse order, which kind of makes sense since it's TAC, which is cat reversed. Okay, so let's just give this a try. So tack, read me, reverse me. Okay, that worked. So second of mine says, I would have printed without lines, reverse order sort by numbers, and then printed without the numbers, or sort R. Can you let us know what that command would look like? Because we can always go back and we could test these. TAC is from 2024. Oh, really? It's that new. Wow. Mr. Crodenbeast, thank you for the info. That is that is some cutting edge Linux technology right there. Okay, so the next one is print the file faces.txt and only print the first instance of each duplicate line, even if the duplicates don't appear next to each other. Know that order matters, so don't sort the lines before removing duplicates. So I mean, this is print only the first instance of each duplicate line, so it's like unique. So the unique uniq command, uniq faces.txt. Nope, that is not it. Oh, interesting. So this is just a bunch of ASCII art. Okay, output does not match the lines. Print the file faces.txt, only print the first instance of each duplicate line, even if the duplicates don't appear next to each other. Don't sort the lines before removing duplicates. So I wonder what the problem is here. I don't see any duplicates. Yeah. Okay, so if we take a look at the original contents of faces.txt, we've got a couple of duplicates here. A couple here. Adding numbers to the file printed would be NL, so cat NL, and then sort it in reverse numerical. Sort it in reverse numerical, then cut out the numbers. That would look like NL, BA faces.txt, sort RN, cut F2. Are you talking about the current challenge, or are you talking about the one from a couple of challenges ago? The previous one. Okay. I mean, the previous one is reverseme.txt. Let me give it a shot. So adding numbers to the file printed would be NL. Sort with the U flag. Sort U. Sort unique. NLBA reverseme.txt cut. Well, let's give it a shot and see if it works. Paste it in. That worked. Okay, so that solution does work here. You can also use the tack command, cat backwards. Okay, so print faces.txt, print the first instance of each duplicated line. Drunken Alcoholic suggests using sort with the U flag, so sort U, sort unique, but they said that we're not supposed to sort the lines before removing the duplicates, but we'll give it a try. Sort faces.txt. Output does not match expected lines. So that doesn't pass the test. So the order matters. So we need to get the original order. This might work if we were able to put it back into the original order. That's the reverse me, that one with the sort R. Sort R? Sort R faces.txt. Okay, so I mean, let's take a look at the contents of faces.txt. We can create our own test file over here. We can create our own faces.txt inside of Kali Linux. Oh. This removed all of the new lines. That's a big kick in the butt. Okay, Mr. Coding Beast says awk is the whole, keeps track of the lines that we've seen, ensures only that the first occurrence is printed. I wonder if there's an easier way to do this. I would have expected to do like, actually wait. Cat faces.txt and then base64 encode it. So I'm going to create my own faces.txt in Kali Linux. Echo just a second. Here we go. Okay, so we've created our own version of faces.txt here. So we just need to figure out where we're going wrong. So my instinct was to do unique on faces.txt. But I guess there are duplicates in here, because in order to use unique, you also need to sort it first. So if you wanted to use unique, you need to sort it first. So sort faces.txt and then pipe it into unique. Pipe it into unique, like this. And this should have no duplicates. The problem with this is that it changes the order, and we need to keep the order in order to solve the puzzle. So how are we going to do this? You know what? Let's just do a little bit of Googling. Linux file, remove duplicates, remove duplicate lines, keep order of lines. Okay, so to remove a duplicate lines from a Linux file while keeping the original order, you have to use the awk command. So this is what Mr. Coding Beast is talking about. Awk scene something something file name. This command uses an associative array to track lines that is already seen. Okay, for in-place editing, you could use awk and then in-place. So using awk to preserve order, command is... Okay, let's give this a try. So we'll give this awk command, we'll run it with faces.txt. That looks like the same, like the correct version. Let's give this a try. Okay, paste it in. That worked. That worked. Okay, so for anybody curious, this was the command that worked. And we're now doing this one. Find primes. Are we doing math? Are we doing mathematics all of a sudden? Okay, the file randomnumbers.txt contains a list of 100 random integers. Print the number of unique prime numbers contained in the file. We want to identify the prime numbers, and then we just want to print out the number of matching numbers. 100 random integers. So let's random numbers.txt. So this is 100 random numbers, sure. I kind of want to get this for ourselves so that we can start playing around with it. Okay, so we got our, let's go ahead and create this on our own machine. Okay, so we've got our own version of the numbers.txt file. We need to find the ones that are, we need to identify the ones that are prime first. But how do you do that inside the Linux terminal? It seems a bit... Do we have Python on here? So let's do which Python? Do we... There's no Python probably. Which Python 3? Biteness, hello, nice to see you here. We're just trying to figure out some Linux puzzles. Print the number of unique prime numbers contained in the file. So Linux file output prime numbers. I had no idea. Okay, to output prime numbers to a file? No. We want to return prime numbers. Linux file return prime numbers. You can find prime numbers in a Linux file using the awk command. Is there anything the awk command can't do? Apparently not. It's a funny looking. Okay, so this is prime n function. A helper function is used to check if the number is prime. Grep with the factor command. This method uses factor to find prime numbers and then grep to filter for lines that only contain a prime number. So factor... So I had no idea. You know, the interesting thing about this this set of challenges is that it introduces you to commands that you never knew existed. The factor command, bit. Yeah, I had no idea the factor command existed. Let's run it on numbers. Factor numbers.txt. Numbers.txt is not a valid positive integer. Oh, okay. So to filter a file, cat and then factor, cat and then factor. Okay. Cat numbers. Pipe it into factor. Okay, so this should be pretty easy. All we need to do is we need to output the number of prime numbers. So we just need to pipe this out into word count, and then we just need to get the number of lines. So we only want lines. Print the new line counts. So pipe it into wc-l 100. So this command should work. Mr. Coding Beast says sequence factor into awk print. I'll also try your command as well, Mr. Coding Beast. Okay, let's go back into the challenge here. We'll paste in our command, see if this works. No? Oh, it's the name is wrong. It's called random numbers. Okay, random. Print the number of unique prime numbers contained in the file. Oh, we also need to... They're unique prime numbers. So we need to get rid of the duplicates first. Alright, so that means we need to sort numbers.txt and then pipe into unique. And then we need to factor the results. 97. Okay. Sort the numbers, then get rid of duplicates using unique, and then run factor on it, and then get the line count. Okay, let's give this a shot. Bit says print only the lines that only have two numbers. Prime numbers have only two factors themselves in one. Oh, are we not doing the same? Oh, so, okay, so the factor command is not the right one. So factor will get... Okay. Bit, you're correct. You're correct. This isn't the way we need to do it. So we run the factor command. And we need to get rid of the ones that have more than one factor. So how do we do that? We run factor, and we have to discard any number that has more than one. So we run factor. How do we do the check? How do we do the check that... So the correct numbers only have one space. Incorrect numbers have more than one space. So we need to figure out in Linux, delete lines with more than one of a specific character. Okay, to delete lines with more than one of a specific character, you can use awk or sed. Awk method uses the character as a field separator and checks the number of fields, which is often the simplest and most pragmatic method. Using awk, you would do awk replace C with the specific character you want to count. And, so the field we're checking for is not C, but space. Awk is king. Awk is a very nice... Yeah, it's very, very nice. Drunken Alcoholic says, same input equals output number or 1. Output number or 1? I mean, in this case, the factor command doesn't include 1, but it only includes the number itself. So we're going to pipe this into awk and then discard everything that has more than one space character. So, okay, this is good. So we just need to count these numbers. So pipe into word count and then get the number of lines. So we'll give this a try. Hey, Monkey Man! Hello, nice to see you here. Yeah, sick in the mind. You're I wonder if that works as well. So NF more than one. He hit enter too fast. Okay. But let's give this a try. Fat finger to the yeah. I mean, I do that all the time. Let's give this a go. Also learning about some new commands. Me too. This is a really cool website. Okay, let's give it a shot. It didn't work. Oh, okay, it's called random numbers. That worked. Okay, great. Yeah, so this is the command you're looking for. And what do we got? Access log 1 and access log 2 are HTTP server logs. Print the IP addresses common to both files, one per line. Oh boy. Okay, so this is the link. Self-note to study awk a bit. Yeah, I think... I mean, after a while, if you're dealing with it often enough, you'll probably do some write-ups with a bunch of different awk commands. Print the IP addresses common to both files, one per line. So we want to get rid of duplicates. So we would probably run like... So first of all, we would look for Linux print lines found, print identical lines in two files. grep. To print identical lines present in two files in Linux, several commands can be utilized. Com is common, I guess. Compares two files sorted line by line. To print only the lines common to both files, use the 1 and 2 flags to suppress lines unique to 1 and 2 respectively. So compare won't get what you need. Really? Well, I mean, I'll give it a try. We'll see what happens when we run the command. Okay, com12 access.log1 access.log.2. What comes out? Com1 is not in sorted order. File 2 is not sorted, not in sorted order. Okay, so let's see. XR says grep access log tr 0 to 9. You know what I want to do? I want to get the contents of these logs so that we can workshop this. Let me go ahead and grab those. Although if these are really big, then oh, it's actually not too big. Okay, so let's cat it out and then base64 encode it. So this is access.log.1. Access.log.1. Okay, and we also want the same thing for access.log.2. Base64 access.log.2. Let's get those contents. Okay. This is just a little trick that we can do for file transfer if we don't want to actually transfer files. Okay, so we should have both of them now. Cat access star. So we got all this stuff. Okay, so the people in chat have been giving suggestions. So XR says grep access log TR0 TR0 9. TR Oh, we should probably put this between some brackets, right? Nope. Oh, wait, I forgot something. Don't forget the period. Okay, Drunken Alcoholic says grep that stuff and then sort. Don't forget the dot. Okay, so oh, you're using grep. Hold on. Operand missing. So the TR operand, we need to do something with this thing. Okay, so grep. We got our regex stuff. I love regex. Okay, so Sick in the Mind suggests using this grep command here. So we get, these are the unique IP addresses. So what we need to do is, well, okay. So one more time, the goal of the exercise is this. I'll just paste in the chat. Print the IP addresses common to both lines, one per line. For IP in something do done. Do something done. So the first thing we need to do is we need to shave everything off until we've got just the IP addresses. So access log.1 and access log.2. There's not the same number of lines in here. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Actually, there's the same number of IP addresses. So if we sort this, then no, sorting it isn't necessarily going to get us some matches. Okay, so XR says grep access log TRC. You have to put the grep in the for loop. I wonder if we can really do it with... It's looking a bit rough. Okay, so let me take a look at what the AI was talking about. Com command compares two sorted files line by line. To print only the lines common to both files, use the -1 and -2 flags. -1 and -2. If the files are not sorted, you have to sort them first. They also have a method using grep. The grep command can be used to search for patterns in files. To find lines in file 2 that exactly match lines in file 1, use the F fixed strings, and then X for exact line match. You know, I kind of wonder about this. Because this isn't going to match exactly. The IPs will match, but the access time is not going to match. So we need to strip everything out but the IP addresses first. And we can do that with this grep method here. So access log 1. Mr. Coding Beast, geez, that's that's a really long command. Let me give it a try. You also nest the greps into com1 too. All right, let me give it a shot. Copy this. Why would you not do the sorting first and then strip everything after space? Does this command work? Okay, so what do we want again? We want print the IP addresses common to both files, 1 per line. Common to both files, 1 per line. So I'll try this command out first, and then we'll try breaking it down because it seems kind of complicated. Actually, maybe not too complicated. Okay, let's we'll try it out. Does it work? It works. It works. So the command is completely legitimate. Okay. All right, let's break down the command. Okay, so let's break this down part by part. So this is the com12 command that compares two files. We're feeding into the file this. So we're feeding into the file the result of grep 0e. So this is just going to get the IP addresses from access.log 1 and then sort them. Then sort them by numeric order. Then so we're supplying to the com command these two arguments. So the first argument is the result of this grep command that operates on accesslog.1. And the second argument is this grep command that acts on accesslog.2. This is a pretty cool command, Mr. Coding Beast. Yeah. It's pretty dang cool. But this gives us just the IP addresses from accesslog1, and this gets us just the IP addresses from accesslog2 in sorted order. That grep looks familiar. It certainly does. Yeah, it does look familiar. Sick in the mind. I don't want to take any credit away from the people who suggested the command. Thank you, sick in the mind. But yeah, let's move on to the next challenge. Okay, so the next challenge is print all the matching lines. All right, so this is the link here. Print all the matching lines without the file name or the file path in all the files under the current directory that start with access.log, where the next line contains the string 404. Note that you will need to search recursively. Okay. Print all the matching lines. So we're looking for... This is more grep, isn't it? Actually, it's find. So we need to find files that start with access.log. No, it's not find. So I can't, so let's just try find current directory name access.log. So they have to start with the name access.log. So it's like this. I have no idea. Okay, output does not match any. Doesn't match any lines. It's not grep. Let's just get all the access.log. So there's only one. There's only one? So you need to search recursively under the current directory. Hold on. Let's just take a look at the current directory first. So there's a var directory under this one. Find and grep. Yeah, that sounds about right. Print all the matching lines, so com probably. So we need to print all the matching lines. Oh, wait. Okay. Let me copy the actual description to everybody in the chat. The wording is weird. Print the lines. In all files under the directory. So this directory, we're looking for files that start with access.log. Where the next line contains the string 404. So we're not looking for the next line. We're looking for... So if it's 404, it's not... We're not actually outputting 404, but the line before it. Okay, -h or no file name with grep. Thank you. So -h is hide file names. So first of all, we need to find access.log, and then we need to do exec on it, right? So exec, and whenever we run exec, we need to do something like this. Access.log star. Okay, is there more than one? There's more than one. Wow. Okay, so all files in the current directory. Right, you're right. Okay, so we need to exec grep, and second the mind suggests grep-h, and we need to look for a pattern. The pattern is going to be 404, but we need to get the previous line. The next line contains 404, so it is what was it, -b? Before, -b for before, right? -b1. So one line before. A, after? No, it's supposed to be one line before 404. So, grep. Let me get the help for grep. Grep help. Context control before print one line before trailing context and leading context. So before context and after context. It should be B. We want the one before the 404. So A 404. We want the one after 404. Hold on. Let me read the description again. It says the next line. Print the matching lines where the next line contains the string 404. It should be, it should be B. So B, and we're looking for the pattern 404, right? And well, we'll try it with B first, and if it doesn't work, we'll try A. Okay, so what is this output? Missing argument to exec. I need to look up how to use exec every time. Find exec example. Okay, exec. So it is curly braces and then backslash and then semicolon. Where are we? Oh, I did semicolon and then backslash. Okay, so we got output does not match expected lines. Try again. Okay, we'll try what Mr. Coding Bee said. So A1. So print the matching lines. Start with access.log where the next line contains the string 404. So grep H, it's definitely B1. Okay. I mean, everybody, you can try this out on your own. I give you guys the exact page for the stuff we're looking at. But Mr. Coding Beast, I'll try your command. I'll try it out. Okay. The -E might be off. So the pattern is off. Did that? Output does not match. So access log star. Yeah, I mean grep doesn't work here because it's not in this directory. But the -E might be off, says Second the Mind. So we'll do B. And the -E is so contains the string 404. I mean, we are getting 404. Hold on. Let's try just this to see what comes out. Missing. Oh, I didn't do it with the. Sorry. Backslash semicolon. So this gets us our 404s. We need to get the previous line. Oh, no. We have to get... Yeah, actually, wait. Mr. Coding Beast is correct. We need to grep out the 404 lines afterwards. So we need to do B1 and then pipe that into grep v404. Nope, that didn't work. What's missing here? Find an awk. But Xmetric, hello, nice to see you here. We need to awk something? Hold on. Maybe I'm not accessing every... We're not accessing the correct files. I might be missing something in this step. Use plus Xmetric. If you've got a command you want us to try out, let us know. This will work. Okay, find type f name access.log exec if exec awk if. Dang, what the heck is going on here? Print previous. This stuff is getting kind of Alright, I'll try Mr. Coding Beast's command first. Plus. So the plus... Okay. Okay, let's give it a shot. So if it works, we'll try to pick it apart and figure out why it works afterwards. That works. Okay. So let me... That works. We'll take a look at what exactly the command is doing in just a sec. I also want to try out Xmetric's command as well. So find... study medicine with pharma ties. There's a toxic, obnoxious trend of tech YouTubers and Linux YouTubers on YouTube talking about if you want security, you have to switch to Linux. Oh, you mean we need to stop using Windows and we need to stop using using operating systems that are not Linux? That's kind of funny. It's not really practical. Xmetric says the reason for that is because all the telemetry and absolute data theft happening on Windows. I mean, if we switched to Linux exclusively for hosting, web servers and stuff like that, or posting everything, then there would be a lot more people scrutinizing Linux for security flaws. I definitely, oh, sorry, there are ads right now. All right, everybody, there's ads. Let's go ahead and put the ads on YouTube, and we'll be back in about a minute. But in the meantime, enjoy these birds. Okay, we'll be back in about 60 seconds. Unit Sola says it's a funny looking bird. Well, the bird comes, they're not all birds, but yeah. Okay, we'll talk about it in just a second. I put on the birds when I do the ad breaks because it makes me happy. I get to share my birds. They don't, they're not pets. They're just the wild birds in my neighborhood. They sure are really excited to see those peanuts, though. Okay, so let's talk about while we've got the video on. Let's talk about what Study Medicine with Pharma Ties was talking about. So Study Medicine says, I'm an ex-user who went back to Windows because, surprise, Linux is overhyped and switching is way harder and downplayed. I mean, you could probably use Linux as a main driver system. You definitely need to adjust yourself. I see merit in both Windows and Linux. I definitely am not championing, like, supremacy of one operating system over the other. If you're doing, security stuff, you need to be familiar with both, well, all the major operating systems. Xmetric, let's not make generalizations here. Thank you. But yeah, let's we'll put the birds away. Mr. Garden Beast asks, have you ever tried Black Arch? No, I've never tried any version of Arch Linux before, Mr. Cutting Beast. I consider myself like a Linux user. I don't consider myself like a power user. I do enjoy Linux. It's just that Arch Linux is a little bit. It seems like a lot of effort to set up. Masterism says, I've been using Linux Mint as my main OS for the past couple of months with zero issues, including being able to play any games that I have tried. Yeah, I mean there are definitely some games that are not available on Linux, but yeah. Xmetric says, is that your side or backyard? Yeah, that's the backyard. Okay, Study Medicine says, switching is hard if you have to grind 100 hours per week and have no time to even sleep. I mean, Linux is going to work for some people. It's not going to work for other people. I don't think that you absolutely need to switch over to Linux to be, to be a safe person interacting with your operating system. I think that that would be kind of an obnoxious thing to see a lot of people say, switching to Linux would solve all of your security issues. I don't think that's the way. Okay, Mr. Cardenby says, I'm new to it. They're fun. I'm a Kali Linux user too. Awesome, awesome. Sick in the Mind says it printed separators. Installing Arch was a rite of passage for neckbeards. Okay, solve using just one more grep. Sorry, it printed the separators? What was it? So Sick in the Mind, if you've got your command, let me take a look and see if you included your Okay, Xmetric included his command. Let's try his command. Okay, Xmetric's command also works, so we will include that in what we've got here. So it looks very similar, yeah. And let's see. Xmetric says backtrack turned into Kali. Kali used to be backtrack. That's well. Xmetric says just use backtrack and call yourself an OG hacker. Backtrack. Um, you're actually quite rare in the Linux community because the rest are quite obnoxious. Well, I, I think Linux is pretty cool. I think it's pretty cool. I think it's one. I feel comfortable working inside of Linux. I feel comfortable working inside of Windows. Just you just gotta use the thing that you gotta use. Sick in the Mind says my solution. Oh, let me allow you. Sorry. Okay, let me try out Sick in the Mind solution. We'll see how it does. Okay, so this command here, paste it in. That worked. That worked. Awesome. So I guess what we're going to do is we're just going to break down these commands before we move on to the next part of today's stream, or the last part of today's stream. Xmetric says, pre-Ubuntu, Linux was a nightmare. Everybody gate kept literally everything. Zero help. Any questions were answered with go back to Windows noob. That sounds like the early InfoSec community. Well, that sounds like the early, what is it called? OSCP community, where if you had any questions, their only response was get good. What was it? Try harder. Al Mexicant says, as someone who does a lot of CTFs, I mostly use Parrot OS. Okay. As for my daily driver, I use Arch now. It works pretty well for my needs. And thank you very much, Tyson, thank you very much for subscribing on YouTube. Okay, and for my daily driver, I use Arch. It's pretty good. I think what's important is that everybody uses what works for them, be it Windows or Linux. I agree with that, El Mexican. Second mindset is I used Fedora pre-Ubuntu. Fedora and Mint were nice. And let's see, Xmetric says I rocked QNX, Debian, Unix, OST Warp. I miss RTOSs. RTOSs? What does the RT stand for in RT? Retro or something else? Okay, so before we move on, so the first part of the command here for all of these commands is we're getting all of the access log files in the directory. So after that, the first two commands use awk to so if previous line was 404, then print the previous line, and then and then we've got this other one where nr greater than 1, print previous, print man. These awk commands always look like magic to me. And where is it? Oh yeah, right. And these ones over here. Second the minds command uses grep, where we grep out the line before 404. And what is this other one? I'm not too sure what this part of the grep command does. So 404. So it looks for the pattern 404, and then this is some regex stuff. Perl, oh, it's Perl regex. Okay. 404 or start of line, end of line, -v to remove. Okay, remove the stuff that has 404 or remove something else, right? Okay, let's go ahead and if you want to continue on with these challenges over here, you can continue on with this one. Print all the files with the bin extension in the current directory that are different than the file named base.bin. So here's the link. Thank you very much for following Luffy Sufi. Thank you. On Twitch. And you know what we haven't done in a while? We haven't done our Hack the Planet. Let's remind ourselves.
Hack the planet! Hack the planet! Shut up and get in.
Okay, let's move on to the last part of today's stream. So for the last part of today's stream, we're going to be taking a look at some Advent event challenges over at TryHackMe.com. So TryHackMe.com has an event that they do every December. It's called the Advent of Cyber. It's 25 days of different little cybersecurity challenges. But this is the original one that they did back in, I think it was like 2018. So we're going to be doing some of these challenges to get ready for the event for 2025. It's going to be happening starting in about, what is it, 6 days? 6 days or so. So we're going to be doing a couple of sections on the stream talking about this room over here. They're basically little bite-sized challenges, and we can see how many of them we can get done today. Hopefully they're not too difficult. And we'll just do this one over here. So just what you want to do is you want to log into TryHackMe, and then you want to access this room. It's a free room, and if you don't have an account over at TryHackMe.com, you can make a free account over there. You don't need to pay for any of the services to use this room. Advent 25 started? Not yet. We're just doing some old Advent stuff to get ready for the new one that's going to be happening next week. So the new one is going to start on Monday of next week. Okay, so let's go ahead and get started. So this is web stuff. So just after you connect to the room, click on the green Join Room button, and then click on task number 3. It's called Day 1 WebEx, a Christmas crisis. We'll start the machine that is associated with the task. What does it say? Improve VM and VPN infrastructure. We've migrated you to our improved regional infrastructure. Your VPN server is now automatically assigned based on your VM region. Select a VM region that's geographically closest to you. Okay. I hope it works. All right, so we should be getting our IP address for the challenge in just a little bit. Just remember to start the machine under task number 3. VIP. You know, they've got a sale going on right now on TryHackMe if you want to purchase like a year of access. I think it's like 40% off right now. Let's see. Let's go over to let's see. I think it means you got to regen your VPN connection. Probably. All right, let's go ahead and get our VPN connection. Actually, you know what? We'll do the first part with the attack box, because the attack box, everybody has access to it. It gives you about an hour of access. Yeah, Black Friday stuff. There's a big Black Friday. It's 4 a.m. here. Mr. Coding Beast, are you somewhere in Europe? I hope your sleep schedule is going to be okay. My guess is that I need to sleep. Goodbye all. No worries, Mr. Coding Beast. Thank you very much for coming by. And yeah, thank you very much for all of the Linux help. Hope to see you again soon. Okay, let me start up the music again. It seems to have stopped. How about some of this? Okay, so what is going on here? So, oh, the web. The internet is one of those things that everybody uses, but few people bother to learn about. As hackers, it is vital that we understand what the web is and how it works. Okay, so we're talking about domain name system, we're talking about IP addresses. Great. Mr. Coding Beast, yeah, no worries. Hope you have a good rest. Get some sleep if it's 4 a.m. where you are. All right, so we're talking about HTTP, HTTPS, we're talking about cookies, we're talking about... Okay, register an account and then log in. So I guess we're going to need to interact with this server. If you're using the attack box, the way you access the attack box is going up to the top of the web page. There should be a button near the just underneath the little icon over here that is labeled Start Attack Box. So click on that and then your attack box will load up. Thank you very much, Nick CCS, for subscribing with Tier 1. Thank you very much. And let's give you a fun video redeem. Nick CCS, thank you for the support. And let's give you the bully bird. There are two birds, one is bullying the other, but they're just so darn cute. Okay, thank you very much, Nick CCS. Thank you. Okay, so this is how we access the room. So this is the attack box on TryHackMe. So just press enter to dismiss the message here. And what we want to do is, Nick CCS says, "Is that your bird cam?" Yeah, it's security footage from. I've got a security camera that looks at the bird feeder. And every once in a while, you'll see the birds doing something weird. Like one bird bullying another. Comrade Soul, hello, nice to see you here. Okay, so inside the attack box, we can start up the web browser in the attack box by clicking on one of these Firefox quick start icons. And then we're going to be using this IP address to access the web page. So it's called Christmas Crisis. This is the virtual machine from task number 3. Okay, so our target IP address is here. We're just going to copy it to our clipboard. After the Firefox page is finished loading up, we can paste in the IP address, or at least we would be able to. Looks like it doesn't look like we can. Okay, so copy the IP address and then go over to this button in the middle of the screen. It's labeled Hide Show Control Bar. After we open that up, we can open up the clipboard and paste in our IP address. Okay, then close the clipboard, paste in the IP address, and hit enter. Okay, so we've got here a Christmas Control Center admin page. They want us to register for an account. So down here, there's a number of questions they want us to answer. So register for an account and then log in. Okay, so click on register. So we need a username and password. How about HackerFrogs? And password is password, I guess. Register. User created successfully, great. And then we'll click on login. Enter username and password. So our username is HackerFrogs. Password is password. Login. Okay, awesome. So we've got a little console here. And what do they want? What is the name of the cookie used for authentication? So inside of the browser, we can take a look at the cookies for our current web browser session by clicking on this button over here. So it's just in the corner. We can go over to More Tools, and then Web Browser Tools, or Web Development Tools. So after that, we can go over to the Storage tab. There's a bunch of different tabs over here. They're different web debugging tools. We'll just go over to Storage. So in the Storage tab, there's a cookie named auth with a certain value. So these are the cookies that let you log into applications and give you a user session. Without these cookies, you wouldn't be able to maintain a session on a website. What is the name of the cookie? So in this case, the name of the cookie is AUTH, auth. So we'll just type that in as the answer. AUTH, done. Okay, and the next question is, in what format is the value of this cookie encoded? We can actually take a look at the value of the cookie itself. We double click on the value, and then we copy. And I'll just print this out over here so that we can better see what's going on. So this looks like, well, if anybody knows what this is, wow. If anybody knows what this is, or what format this is, let us know. Okay, so it looks like a bunch of numbers and letters, but there's a very special word for the type of format this is in. So this is what is called a hexadecimal string. So hexadecimal strings, these are 16-bit numbers. Sorry, not 16-bit numbers. These are base 16 numbers. So the regular decimal numbers go from 1 to 10, but hexadecimal numbers go from the numbers 1 to F. So you say, what is 1 to F? Actually, they also go from 1 to 10. But hexadecimal numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, but then they go into a few different numbers. So A, B, C, D, E, and F. So 10 in hexadecimal is actually A, and 11 is B, 12 is C, and 15 is F. So 16 in hexadecimal is actually written as 10, but this gets a bit confusing. So we usually like to prepend hexadecimal numbers with the 0x to let you know that you're dealing with hexadecimal base instead of regular one. CO Mulder says, company, best festival company, username HackerFrogs. Thank you for letting us know. Okay, so we can actually translate this. So this could be used as a type of encoding, and CO Mulder managed to figure it out. So what we can do with this cookie value is we can go into, I don't know, we can do hexadecimal encoding. Hexadecimal encoding, we can use some sort of hex decoder tool, and we can just paste it in over here. Wait. Yeah, so we can use a tool like this to get the original value of the encoded cookie. So the encoded cookie looks like this. But let's answer a couple more questions. So what is the format of the value of the cookie encoded? This is hexadecimal. Hexadecimal? Okay, so having decoded the cookie, what format is the data stored in? So they're talking about this thing right here. And let's... So this particular format right here, this is what is known as JavaScript, what is it? JavaScript something format. So the format is actually called JSON. It stands for JavaScript something notation. Let me look it up. Okay, JSON is JavaScript object notation, okay? So JavaScript object notation consists of a bunch of different objects. So the JavaScript objects have to be between these curly braces here, and usually the objects are usually separated, well, the key of the object and the value of the object are separated by the comma. Each, if there's more than one object inside of JavaScript or JSON format, you separate them with the comma, and then we would do key and value again. So here we've got company, and then the best festival company, and then this is one of the objects. So the second object in here is username equals HackerFrogs. So yeah, so this thing is JSON. Where are we? Back here. So the answer here is JSON. Okay. So figure out how to bypass the authentication. What is the value of Santa's cookie? It doesn't give you very much, huh? It just says figure out how to bypass the authentication. Okay, so this is what you can do. If you know that the object is encoded using hexadecimal here, and we can decode this, what we can do is we can go in here and we can edit our username. So in this case, our name isn't HackerFrogs, it's admin instead. And so after we adjust this, the hexadecimal values are also adjusted. So we can just copy this. We'll paste this in. Unfortunately, we've included a bunch of spaces in here. I think what we can do is we can get rid of the spaces. Let me see if I can do something about that. So inside of here, we're just going to echo this out. We're going to delete all of the spaces. And then it looks like this. Okay, so let's grab this. Yeah, second in mind. It's tr delete the spaces. So we're just going to copy this. We're going to go back to the application, and we're going to plug in the new cookie. Okay. Oh, okay. No. What is the value of Santa's cookie? So we don't want admin, we want Santa. All right, let's go back here. We'll just adjust our username so it's not admin, it's Santa. I wonder if we probably don't need the S to be capitalized. I guess we'll figure it out in just a second. We can copy this. Okay, let's try that again. Okay. Oh, the time for the new challenge. You're correct, Jason. Thank you. Let me let's do 2 hours. We're probably not going to use up the full 2 hours, or maybe we will. Who knows? But 120 minutes. Start the timer now. Okay, so this is the new cookie here. And let's go back to the web application. We will, well, we need to paste in the cookie into the clipboard first. And then we can go in here, delete the previous value, plug in the new value, and then reload the page. Oh, you know what? You know what we should do? We should validate the value of Santa's cookie by pasting this in. Okay, that was the correct cookie. Great. Now that you're the Santa user, you can reactivate the assembly line. Okay, so can we click on yes for assembly? We'll click on yes for everything. Do we get a flag? Shouldn't we get a flag? Oh no, there was 2 more. Okay, now we get a flag. So after we reactivate everything, we get a flag for the challenge. Let me copy that, and then let's submit this. Paste in the flag. We're done. Okay, so we can move on to the next thing. Okay, Ahmed. Hello, nice to see you here. We're just doing a bunch of little mini challenges, which you can do yourself over here, if you want to. Learn Cyber in 25 days. This was an event from 2018. I think this is 2018. This was the first year that that TryHackMe was in business, and this was the first Advent event. Okay, let's take a look. Alright, so we got day number 3. For some reason, I've already completed day number 2, but let's complete day number 2 again. Before we do day number 2, we need to shut down the machine from day number 1. So we're just going to go up to the top. We're going to click on Terminate. Okay, and then we can go over to day number 2. So under day number 2, we can start the machine. We just have to wait for about a minute before this works. So because we shut down the machine for day number 1, if we reload this page, it shouldn't give us a response. Okay, let's try making everything a little bit bigger. So this particular task is called Elf Strikes Back. And what are we supposed to do? Get parameters and URLs. Okay. So we're talking more about web app stuff. So in this case, we're talking about, oh, we're doing file upload attacks. Awesome. Alright, so we're talking about file upload attacks. We're talking about sending reverse shells via file upload, which we can use to get direct access to the web server. And we're talking about setting up reverse shell listeners. Very, very good. Okay. So for this, I mean, I've already solved it. I think I can reset my progress. That's what I'm going to do. Okay, so in here, where are my options? Just a second, everybody. Yeah, options, okay. Reset progress. And then we've got our IP address. We need to copy the IP address like we did last time, put it into our clipboard. and then paste in our IP address for the machine that we're going to be accessing. Then in the attack box web browser, we're going to go to that website. Okay, so it says here, you're not signed in. Enter your ID as a get parameter or ID your name here. Okay, so this is talking about sending HTTP parameters along with our GET requests. So let's take a look at what string of text needs to be added to the URL to get access to the upload page. Upload page. Interesting. Okay, so let me grab this right here. So this is an example of a URL parameter. And if we go over here, where are we? Here. If we go over here, we've got our, if we've got a usual like address, HTTP IP address, say, and then on the end of it, we will put in this parameter here. $ID equals your ID here. So what this is looking for is it's looking for like a number like 1, 2, 3, 4, or something that is going to get us additional access to the page. So URL parameters are sent with the usual URL in order to get a specific response from the web page. And in this case, it should let us log in, but let me see what's going on here. Note down your ID number and navigate to the displayed IP address. Okay, so the ID number is this over here. So let me just copy that. So we're just going to put in ID number equals this. Okay, if you're doing this at home, you can use this. Just stick this onto the end of the URL over here. So our actual URL looks like this. Of course, you're going to need to use your own IP address. Your IP address and my IP address are going to be different. But if you give this request, then we get access to the factory. Protect the factory. If you see any suspicious people near the factory, take a picture and upload it here. So this is a file upload endpoint. So that means that we can upload files from this part of the website, and well, they were talking about how to upload malicious files. So we can upload malicious files, and if we're able to locate the files that we upload, then that would be really, really bad for the security of the website. So we could select something. Let's just make an example file. So they're looking for PNG images, I think. Find. So we're looking for PNG files in the file system. I'm just looking for like an example that we can upload. Yeah, maybe we could use this one right here. I'm just going to copy this to our current directory, then we can try sending it off. So we're just going to copy this file to our current directory. I think this is the root directory. Yeah. All right. So we'll try uploading this file first. Oh. We just want to use we want to use our current one here. Okay, so we're just going to go into the root directory and then upload this file. So zap32by32.png. Okay, and then click on submit. So it says file received successfully. So file successfully, that doesn't necessarily mean that we can take a look at it. Typically inside of the web app, there's a directory where all the stuff is being uploaded to. Alice Radio says, I'm just dropping in before I fall asleep because of GF. If you're having, I'm sorry to hear that you're having problems with your girlfriend. If that's the case, I'm sorry to hear that. Okay, so we're going to try to access. We're going to try to access the uploads endpoint. So I'm just kind of taking a stab in the dark that the web page we want to access is the uploads directory here, and it looks like the file that we uploaded ended up in the directory. So if we wanted to weaponize the file upload function in here, okay, glad to hear you're not having any issues. That's great. Cybernetic Dante says, Merry Hackmas. Merry Hackmas to you, Cybernetic Dante. This is the room we're doing right now if you're interested. Okay, so what do we need to do from here? We need to upload a malicious file. So it's a good practice to upload the files, yeah. So I'm going to grab a very simple web shell that we can upload. So when we're talking about web shells, we basically mean a little bit of code that we can use to execute system commands on the target. There's a very common website that a lot of us pen testy people like to do CTFs, we like to use. It's called RevShells, and we can get a bunch of different commands that can get us different types of access on different targets. So we're dealing with a PHP application. We know that we're dealing with a PHP application because the web page over here, it's called index.php. So yeah, so because the name of the file is index.php, that means that PHP code can run on the website. So we're just going to get some malicious PHP code. So the code that we're going to upload includes this right here. And this payload will let us run commands on the target through the zero URL parameter. And how do we do that? Okay, so we're just going to go into the terminal. Oh, I shouldn't have opened up a new one. Hold on. Where's my terminal? Here? Okay. So we're just going to create something called shell.php. Actually, we'll call it web shell, because this is specifically a web shell. I'm going to paste in our malicious PHP code. Okay, and then we will save out this file. So we're going to try to upload this page, or this particular file. If we're able to upload it intact with the PHP extension, then we can run whatever commands we want through it. Okay, let's go back to... So we're not logged in. Hold on. Okay, we got this saved. Okay, so we'll select the malicious file. So webshell.php, we'll try to upload it. There might be filters in place that prevent us from doing this. So it says invalid extension. So it's checking to see if this is a valid picture file or not, because it says take a picture and upload it there. Upload it here. One thing we could do is we could try to mess around with the name of the file. So if it's expecting a PNG file, we could rename the file. So we could rename webshell.php to webshell.png.php. It could be that it's just looking for the characters PNG, and if that's the case, then we can get around it by just renaming the file. Let's give it a shot. Okay, let's try uploading this. File received successfully. So we were able to bypass the filter by renaming the file. So we're just going to go over to the uploads directory. Okay, and we see webpage.png.php in here. We click on it. we don't see anything. The reason we don't see anything is because we didn't send a command to the web shell. And we can send a command to the web shell by doing $0 equals whatever command we want. So who am I? And we get a response. So we were able to run system commands through by uploading a malicious file and then accessing the file via the web server. So from here, what do they want us to do? Okay, what string of text needs to be added to the URL to get access to the upload page? Get access to the upload page. Are they... hold on. Let me open up another tab. Okay, so this is going to be the uploads page. This is going to be... So I think they were looking for the extension, right? So the extension that we added on was this. Check. Yeah, this is what they wanted. The ID, the URL parameter that we used to log in. Okay, so it says what type of file is accepted by the site. So it's looking for... So it's talking about what kind of files are legitimately supposed to be uploaded. And it's picture files, image files. Image? Okay, so bypass the filter and upload a reverse shell. In which directory are the uploaded files stored? So we found out by guessing that these all end up in the /uploads directory. Okay, activate your reverse shell and catch it in a netcat listener. What is the flag in var www flag.txt? We're actually going to skip the part where we get shell access. We don't need shell access to read the flag.txt file. All we need to do to read the flag.txt file is use the web shell. So in a lot of cases, the functionality of web shells oh, hold on. Okay. Hold on, let me do it in this tab instead. Okay, so we're going to be using the web shell file here. All we need to do to read var www flag.txt is just give the command. So 0 equals cat /var /www /flag.txt. This is a PHP get command web shell. Yeah, so this is PHP get command web shell. The actual payload is just this right here. So 0 is the name of the URL parameter that you're supposed to provide, and get means that it's a get request. So it's fairly simple. Not all PHP web shell payloads are going to look like this, but this will work in a few different circumstances. Sometimes you need to use some different ones. Pertinax asks, what do you think about Bitcoin? I mean, it's a thing. I'm not invested in it. It's certainly really, really interesting how it caused this whole like cryptocurrency, what is the word, speculation market. Not something I think too much about. I suppose if I had a lot of cryptocurrency, I would think more about it. But what were we doing? Yeah, so we just need to read this file here. So you reach the end of Advent of Cyber Day 2. Okay, and we got our flag. So we're just going to copy the flag. And then copy it from the clipboard. We can submit this and we can finish this day. Okay. Done. Let's move on to the next day. So before we do that, we need to shut down our machine for day 2. I'm going to go up to the top. We're going to terminate the machine. Pertinax says you should research how it works. Well, I mean, Bitcoin and all these other cryptocurrency, cryptocurrency types, they're all recorded on the blockchain. So the blockchain is a digital ledger that is protected using strong cryptography. The blockchain keeps track of transactions, and it basically keeps track of where all of the Bitcoin is, or where all of the cryptocurrency is, because it's something that everybody can get access to. Okay, so day 3, we'll start the machine here, and then we'll access it in just a couple of minutes. So let's start up a new tab. Let's close the tabs that we were using. So what's going on here? So understanding authentication, understanding the use of default credentials, bypass a login form using Burp Suite. I don't know if we're going to have to use Burp Suite, but we'll see what's going on here. So authentication is the act of logging into an application in this case. So we're talking about default credentials. So it used to be the case that a lot of software came with default credentials. Basically, the admin account was well known, and people wouldn't change the passwords for their admin accounts, which would lead to really, really bad things. I'm guessing that's how we're going to be accessing this next challenge here. So default credentials, directory attacks using Burp Suite. Okay, so it looks like we might be doing some brute forcing attacks as well, using some sort of tool. So in this case, they tell us to do it using Burp Suite, but we could use a few different tools to do online brute forcing attacks. Okay, so it teaches us how to do cluster bomb attacks. It's been a while since I've done cluster bomb attacks inside of Burp Suite. The problem with Burp Suite for this kind of exercise is that it's very, very slow on purpose, because we're using the unpaid version of Burp Suite. But let's go ahead and access the web page. So we got our IP address here. Just going to copy it. Jason asks, why is my TryHackMe machine not activating? Are you talking about the Are you talking about the day 3 machine, or are you talking about the attack box? Mexicant says, that's why I use Zap Proxy for some of these CTFs. Yeah, Zap Proxy is pretty good for a few different attacks. I've also heard that Kaido is really good as well. I've never used Kaido before myself. The day 3 machine is not starting up for you. You might want to try reloading the page. The other thing is that it could be that you haven't terminated the previous machine. So you want to go up to the top of the page. You want to make sure that the machine, there isn't a machine that's already on. If there's one that's already on, you need to terminate it first. Mexicant says, I used Kaido before. Awesome. So how does it compare to Burp Proxy in your opinion? Okay, so let's go ahead and copy this IP address, and then we will access it on our attack box machine. Okay. So this is the Santa Sleigh tracker. Great. So they were talking about default credentials previously, and it could be like admin or admin password. Okay, so admin password. Okay, looks like that wasn't it. Okay, so what do they want us to do? So deploy your attack box. Okay, we've done this. Use Burp Suite to brute force the login form using the following list for default credentials. Username, password, root, admin, password, user. Okay, we could we could do the brute force attack. Okay, so this is actually very short, so we can do this. Let's go ahead and start up Burp Suite. So let's see, Burp Suite, we can access it from the side menu, and it's this blue icon over here. Ian here says, hello Ian, nice to see you here. Almexcan says, it's actually pretty good, while some features are limited due to, oh, there's paywalling in Kaido as well, okay. You still get to use brute force attack with reasonable speed. Oh, in Kaido. Yeah, I mean, I haven't gotten around to it. I really want to check it out. Okay, so this is Burp Suite. So Burp Suite Community Edition is, it's a bit of a pain in the butt to use on the attack box. I'll show you how to use it. Okay, just need to wait for the thing to finish loading up. We got 20 minutes left on the attack box. So after the attack box runs out of time, we'll log in using our VPN key. Hopefully it works. I've been having a bit of trouble with TryHackMe access with the VPN key in the last couple of weeks. Hopefully it works this time. Still loading. Use Burp Suite to brute force login the form. So the thing about online brute force attacks is that they're a bit risky because there's all sorts of protections you can do for online attacks to prevent them from happening. But in this case, they haven't included any. Okay, so we're just starting up Burp Suite. So Burp Suite on the attack box in particular, there are a couple of settings we need to adjust. This is how we do it. So we go into settings, and then we go into Burp's browser, and then we scroll down to browser running over here. We need to check on this box over here that says allow Burp's browser to run without a sandbox. This is going to allow the Burp Suite browser to run properly, otherwise it's not, which is not great. But anyways, let's close out the settings. So Burp Suite is a very commonly used security tool. It intercepts all the traffic that goes between the browser and the website. So I'm going to start up the browser over here, proxy open browser. This is going to open up the Burp Suite browser, which is connected to Burp Suite. It's a lot like a regular old browser, but it's all the traffic that runs through the browser is going to be sent to the Burp Suite tool. Mexcant says, Kaido has a few features which are not behind a paywall and are good for pen testing and bug bounties. That's good to hear. Yeah, Burp Suite needs a competitor because Burp Suite it's got pretty much close to a monopoly on web app security testers. Okay, so let me grab the IP address from the other website here. Okay, and then we'll go back to the Burp Suite browser here. So the Burp Suite browser, it's a type of Google Chrome. It's called Chromium. Oh no! There's intercept on in Burp Suite. I hate this. Okay. So inside of Burp Suite, there's a certain switch you can switch on and off. It's called intercept. So when intercept is on, that means you need to manually accept or drop all of the web requests that are made through the Burp Suite browser. So we want to make sure that intercept is turned off. And then we can use the browser normally. Okay, so we're just going to send just a test username and password here. Sign in. Okay, it doesn't work, but that attempt was recorded by Burp Suite. So we're just going to go into the proxy HTTP history tab, and then we're going to get our login post request. Okay, so this is all the information that was sent between the browser, and this is the response that was sent back. In response. So what we can do is we can put this into the Burp Suite repeater tool. Oh no, wait. We're going to put this into the intruder tool. So the repeater tool is used to repeat web requests, and the intruder tool is used to do brute force attacks. So we're just going to go over to the proxy. We're going to take the post request to log in. We're going to send it to the intruder. And then afterwards, we can go to the intruder and we can set up the attack. Okay? And they say that we've got 4 sets of credentials to... Actually, we only have 3 sets of credentials to check. Okay, so what we can do inside of here is we need to set up where the payloads are going to go. So over here, username equals test and password equals test. These both need to be set as the payload. Okay, so we go in here, we highlight the word test, and then we add a payload location here. Hork Ryan, hello, nice to see you here. Just here to say hi. Hope you're having a great stream. Thank you, Hork Ryan. And yeah, so we're just doing some exercises here. So we're just going to add test username as one of the payloads, and the password is one of the payloads as well. So highlight this and then click on add. Ooh, these should be different payloads though. We need to change the type of attack we're doing. So we're not doing a sniper attack, we're doing a pitchfork attack. So allocate a payload to each position. Intruder iterates through each set in parallel. Okay, so pitchfork attack. Let me get rid of this payload. I'm going to clear, and we're going to add. Oops. Add. I used the last one. The last one. Okay, we're just going to go to our payloads. We need to set up our payloads for the pitchfork attack. So one is going to be root. The one is going to be admin password. The last one is going to be user 12345. So we're just going to do payload 1 and simple list. Okay. So we're going to add a new item. The first one is going to be root, add. The second one is going to be admin, add that one. The third one is going to be user, add that one. Okay, and then we're going to switch over to payload 2. So payload 2 is going to be the actual passwords. First item is root. Second item is password. And the third item is 12345. Okay. Furnace X's cluster is the one where it uses all the permutations of the payloads. Yeah, I mean, I haven't done a lot of brute force attacks using Burp Suite, but the pitchfork attack is basically gonna pair each one of these. So root is gonna go with this, admin is gonna go with password, and user is gonna go with 12345.
Hey! Who are you people? What do you want from me?
You want the numbers, Mason. You want the numbers. That's all we've ever wanted.
Yeah, that's all we ever wanted was the numbers. If you know where that's from, then you are a cool guy. Cool person, rather. Anyways, let's go ahead and... so the payloads are done. And I think all we need to do is... Let's see, let's switch back. Let's see, settings, payloads, resource pool. let's give this a shot. So we'll start the attack. And that happened really fast. Okay, so root admin password and then user 12345, and we got one that has a different response. Actually, wait. It looks like it's the same response. Responses received. Okay, we got a post to login, and then with the other one we got post to login. The only difference is the length is a little bit different. Pitchfork assumes user pair passes. I hope so. Okay, so we can also, I think we can also, so the thing is that with these attacks here, we need to figure out which one was actually successful. So off the bat, I'm not too sure which one is successful because everything looks about the same. The only difference is one has the content length is slightly different. This is a different content length. So this might be what we're looking for. So admin and password. The rest of these, actually wait, they're all different. The content length is all different. Challenge might be playing using, that's your request, oh, that's the request length. Sorry. Content length 96 versus, so they're all 96. Oh, username incorrect, password incorrect, username incorrect. So this lets us know that admin and password, the username was correct, but the password is not correct. Okay, so we can actually send the same we can send the same attack, only not in pitchfork mode. Instead, we'll try using cluster bomb mode. Okay, get out of here. And we'll go back. So, I mean, we could do this manually pretty easily, but I just want to illustrate how. So, cluster bomb attack. Allocate a payload set for each position. Intruder iterates through all the possible combinations. So let's try this one instead. Okay, so how did that go? All right, so everything went. This one has a different length. So the response length in this case was 260 as opposed to all the other ones, which are 314. So if we take a look at this, then in the response it says found, redirecting. So this is probably the correct password. So it's admin12345. So we can go back in manually. So admin12345 and then click on sign in. Okay, and now we've got access. And we got a flag. Truly a password of all time. That's true. That's true. And thank you for pointing out that I was looking at the wrong number before for a sec. Okay, we'll copy that. We will go back and copy the flag, submit the flag, and then we're finished. Cool. Okay, so before we start the next one, we should probably turn off the attack box because we only have 7 minutes left on this thing. Okay, so we'll go up here, we will terminate our current machine, and then we will terminate the attack box because I've run out of time on the thing. Okay, so before we move on to the next thing, I need to download my VPN key. So I'll go to view profile. No, I want to go to access. Hold on. Where's the access thing? Manage account, resources, practice, compete. Was it /access? Let me go back to the room. Access machines, here it is. I didn't see this thing before. Okay, access machine, you're disconnected. We want to use OpenVPN. And let's see. So view the dedicated OpenVPN access page. Cool. Okay, so we're using the regular VPN. We're going to download the regular configuration file. And it's going to give us US East 1 the Shy Hat. Okay, so this is my VPN key. All right, we're going to try to log on to the network, or actually VPN into the network is what we're doing. Let me just call this our VPN connection tab. So we downloaded it to the downloads directory, and it's like USA East. USA East, interesting. Anyways, we can use a command soup and OpenVPN with our key name. Okay, so anytime we VPN into a new network or a network using a VPN key, we have to do that as the root user. Hopefully this works. Okay, so if the VPN connection connected properly, we should have a new interface. So the interface we're using in this case is called RingZero, and we have an IP address on this network as well. So this means that we have access, well, we should have access to the machines on this subnet inside of the TryHackMe network. Okay, so we're gonna go back and we're gonna start up our new machine. So we're doing day 4. Okay, so in day 4, we're gonna start up the machine. And then after the machine has finished starting up, we will access it on our Kali Linux box. So we're talking about fuzzing. So fuzzing is fancy brute forcing. So what are we going to do? Oh, okay. So we're talking about directory busting. So GoBuster is a tool that you can use for directory busting. And directory busting is basically trying to find out what web pages and what directories exist on a web application by testing with a really, really big word list of common directory and web page names. Okay, so let's take a look. So they want us to do some directory busting, and they want us to also use the wfuzz tool. So the wfuzz tool is one of these fuzzing tools that we can use to get more information from web applications. In this case, they're looking for specific subdirectories here. Okay. Ooh, I didn't want to click on you, Mr. Bot. Okay, but anyways, we'll just go down. Let's see, challenge. Deploy both the instance attached to this task and the attack box, okay? Navigate to this web page. It's up to you to decide if you want to create the web page yourself or use a larger word list in here. The word list is also available for download if you used your own machine. Okay, so they're giving us a word list to try on the web application. So I'm just going to download it myself and I'm going to save it to my temp directory. So I'm just going to wget this down. Okay, and this word list is just called word list. So if we take a look at the contents, it's just a bunch of numbers. It's just a bunch of numbers. Okay, that's good. Okay, so how to approach this challenge? What do they want us to do? Once you have both deployed, open the Firefox on the attack box and then paste this in. Alright, we've got our IP address. So we're just going to copy this, and then if we're connected to the machine, we should be able to ping the machine. So I'm going to give it a try. So I'm going to try pinging this IP address. If it works, that means we've got access to the machine. Okay, so we do. That's great. So we're just going to go over to our web browser. And we're going to paste in the IP address here in our web browser. You have been defaced. Your forums are gone. And we got a fun little graphic here. That's great. So let's go to the task. Given the URL shibes.xyz.api.php, what would the entire wfuzz command look when you query the read parameter using the word big_list or the word big.txt? Assume that big.txt is in your current directory. For legal reasons, what are we doing? Brian McGrath, thank you very much for subscribing on YouTube. Much appreciated. Thank you, thank you. Let's give you a fun video redeem. How about some of the Desert Frog? Okay, so they're talking about given this URL, and I guess this isn't really what we're doing on this box, but they're just looking for something. There's a very angry frog. That's true, that's true. Okay, so let's go into to take a look at this. So we're trying to do some API fuzzing, right? Or what do they want from us? What would the entire wfuzz command look like to query the breed parameter using the word big_list? The word list big.txt. Assume big.txt is in your current directory. They've also got this format right here that we can copy. So it's going to look something like this. So we're assuming that we're using wfuzz. And they're looking for HTTP shibes API, and we're scanning the breed. Was it the breed parameter? So breed equals fuzz, something like this. So we're also using the big.txt list. So big.txt. What does the command syntax look like for wfuzz? I just need to look it up real quick. So I think they included up here. Yeah. What is this, the exact command right here? No, it's not the exact command. It looks kind of similar though. Okay, so it's fuzz-c-z file. Okay, so this should be the answer for the question. I personally don't use wfuzz. I use another program called FFUF when I want to do fuzzing most of the time. But this looks a little bit no. This is the right length. Okay, let me give this a try as the answer for the question. Okay, paste it in. Done. Great. Use GoBuster against the target you deployed. Find the API directory. What file is in there? What file is there? Okay, so we're using GoBuster in this case. Which room is this? This is the Learn Cyber in 25 Days room. It's one of the Christmas events. We're currently looking at task number 6, which is day 4. Okay, so they've got an example command for GoBuster over here. Let me just grab it. So GoBuster, I mean, I still use GoBuster every once in a while, but there are so many different directory busting tools. Let's just talk about what exactly the GoBuster format looks like. So GoBuster, we're running it in directory busting mode. We have to provide a URL. We have to provide a word list, and then we have to provide some extensions to look for. In this case, we look for like PHP files, we can look for TXT files, and HTML files. If you don't provide any of these, then GoBuster is just going to look for directories, and it's not going to look for file extensions. Okay, so wordlist.txt. Let me just copy this. Actually, it's copied. We'll just go to our terminal. What should we call this? We'll call this our web app enumeration tab. Okay, and what we need to do here is we need to replace this URL here with our IP address that the target is on. So the target is this here, this IP address. Okay, so just sub that in. We need to provide a word list. So the typical word list we use for these kind of CTF exercises is in user share word lists, dirbuster, let's see, directory list 2.3 medium.txt. Okay, and so this is going to run GoBuster in directory busting mode. We're looking for an API according to the question there. So let's go down. So use GoBuster against the target you deployed to find the API directory. What file is there? So we're looking for an API. It's like a 3-letter file extension. So it's going to be, I'm guessing it's going to be like a PHP file or something similar. Oh, it's just /API. Okay, so if we just go to /API, we can navigate there directly. Or maybe we can do some fuzzing inside of this directory itself. So let's go back over here. We'll go to the API directory. Okay. So inside the API directory, there's this site here called sitelog.php. So this is the answer for the next question. Okay, check. So it says, fuzz the date parameter on the file you found in the API directory. What is the flag displayed on the correct post? So fuzz the date parameter on your file in the API directory. Cool. So this is the full path that we want to look at. And what we want to do is we want to do some fuzzing. So I'm thinking that we're going to be using the wfuzz command here, and we're just going to replace the URL in this case. We don't need the data because we're not sending a post request. So in this case, the file is going to be, I think it was just called word list, no txt. And we want to send it to a specific URL parameter. They said it was the date parameter on the file. So date parameter implies that date equals fuzz. So this is the fuzzing point. I'm not exactly sure if this is the correct command syntax because I don't use wfuzz, but I'll give it a try. Okay, let's move down to web app enumeration, and I think, all right. So it looks like one of these came back with a different response. So sitelog.php date equals something something. Hold on. Let me just put this between some quotes to make sure. So these all come back 0 length and 0. So one of these payloads came back with a different response. So we get 13 characters and we get 1 word in the response, and this is the payload here. So we can manually test this by going over to the web app here, and we'll just insert date equals this. Okay, and this is the flag for the challenge. Copy that. So we were able to successfully do some fuzzing. So we fuzzed this particular API endpoint to figure out what a valid request was. Okay, and inside of the so while fuzzing, we used a bunch of different words inside the list. We were able to find a match. Okay, so back over at TryHackMe, paste in the flag. We're done. Great. Okay, let's move on to the next day. So we've just finished day 5, or is it day 4? Day 4 done. We'll do day 5. Before we start day 5, we need to terminate the machine for day 4. Okay, so after that's done, we'll do day 5. Saint of Ice, nice to see you here. Thank you very much for lurking. Okay, so let's see. Someone stole Santa's gift list. Alright. Oh, we're doing SQL injection. So SQL injection is basically injecting your own command into a database command. This is often done for, well, to get around like login restrictions, or basically using the injection as a way to log into an application without a proper username and password. We can also use it to get data from the database, or to leak out stuff. Okay, so they talk about quick introduction to the SQL programming language that is used to make the queries. Okay, so we're going to demonstrate how to do this attack in just a sec. Ronan asks, how did you find serverlog.php? Yeah, so serverlog.php, we found it by running our GoBuster attack, and the GoBuster attack was able to find the API endpoint. So after we found the API endpoint, we manually navigated to the API endpoint, and we were able to find the serverlog.php page. Okay, so they talk a lot about, they give you a lot of information about how to do the attack and how to use the different tools. So stuff like SQL map, using Burp Suite to investigate the application. I think I should be able to wing it. If I'm not able to wing it, I'll take a look at the stuff, at the materials from the room. But first of all, let's go down and see what they want us to do for the questions. Okay, without directory brute forcing, what is Santa's secret login panel? Okay. I see what they're putting down. Alright, so we'll go over to this IP address. Unable to connect. Hold on. Did I copy the right IP address? Let me check it one more time. Okay, so the other thing that we should do is we should give these servers a little scan. So I'll just call this port scanning, this tab here. We'll nmap scan Okay, so there's port 8000 open, there's port 3000 open, and there's port 3306 open. So port 8000 is open, it's got an HTTP alt. There's no port 80, which means we can't use the default web browser port. We just need to go over here, and we just need to append :8000 to access the web page. Or at least we would be able to. Let me make sure that I'm... Here we go. Luffy Suffy says, I've enjoyed your stream as a newbie. Thank you very much for your work. Gotta head to bed now. No worries, Luffy Sufi. Nice to see you here, and yeah. Welcome on in. Hope to see you next time. Dibs104, thank you very much for following on Twitch. This is a place to exchange your Christmas stories and wishes. So this is a website. So typically, the login form is going to be at something like /login or /admin. /login no, /admin. Okay, so what do they want us to do? Let me just go to the question. Without directory brute forcing, what is Santa's secret login panel? So it's going to be something like secret, but the other thing we could do is we can take a look inside of the web page source. So on any web page, we can view the page source. It'll show us the source code that was used to create the page. So we might be able to see some hidden information in here. Okay, I don't see any hidden directories in here. So it's saying that we shouldn't do directory brute forcing. Santa, we could start looking for some stuff. Okay, let's go back to Santa's forum. So Santa's forum is here. If we wanted to do some database injection, SQL injection, database injection, we would need to find somewhere where we can put some stuff in. Does static have open listing? Static. So we did see a static directory. Thank you very much for letting us know about that. Looks like looks like the answer might be no. So it's /static/styles.css. Let me try. We can access this directly. Wait, no, we can't. So this doesn't let us see. This doesn't let us see anything that we're not supposed to. Okay. All right. So without using brute forcing, what is Santa's secret login panel? So I'll take a hint. The name is derived of two words from this question. Santa panel? Santa panel. That's my guess. Let's give it a shot. So /Santa panel. Okay. So we got access to Santa's secret panel here. And I guess we can answer the question as well. So the question /Santa panel. Okay. Visit Santa's secret login panel and bypass the login using SQL injection. So we're talking about SQL injection here. And you know what? I'm getting better at explaining how SQL injection works in this particular case. So let me try to explain. So the SQL, so the way we log into an application is that there's a query made to the database to select username and password from the users table, where the username is legit user. Well, let's just pretend that we've got a legit user, and password equals legit password. Okay, so we're assuming that the user is going to put in their stuff over here. So this is where, so the stuff in yellow, this is where our user input would be put. So for example, we would put in, I don't know, admin as the username, and the password would be admin pass, you know, just for fun. What this is checking over here is it's checking that that this is a valid pair. So that there's a inside the user table, there is somebody named user, and that their password matches with this. Okay, so send breaks with the select star statements. I mean, usually it's just going to check these two things. So it's going to check that the username and the password are a matching pair, or that there is a matching pair that exists in the database. What we're doing when we try to inject into it is we're trying to put in some extra SQL commands in here. So instead of giving like the name of a user like admin, we just quote out this thing so that it becomes where username equals blank thing. Username equals blank, and then we comment out everything on this side so that none of this stuff actually applies. Instead, what we're going to put in here is we're going to put in a malicious payload. So our malicious payload is going to be or 1 equals 1, like this. So or what this statement here is looking for, it's looking for something that returns true. So true means that there is a matching username and password, but instead we're providing our own payload. We say that this could be true, the matching username and password, or 1 equals 1, which is a true statement. And it's going to give us a true statement every time. So, oh yeah, when OK says do a return. So the check here is, it's checking to see if it's just looking for a true statement. So we could provide a true statement for providing a legitimate username and password, or we can give this payload here, which always returns true. And then we make sure that everything else in the statement is not rendered, or is not, it's treated as a comment by giving these characters here. So I can demonstrate this here, and so username is or 1 equals 1, commented out. Password could be anything, because this actually doesn't get rendered out by the application. So it says, welcome back, Santa. Does it work on HTTP 2? I mean, I'm not sure about HTTP 2. HTTP 2, I mean, HTTP 2 doesn't really affect whether or not SQL injection exists, or at least it shouldn't. Daniel, hello, nice to see you here. Do an iframe inject. I mean, that's not what we're doing here. We're just trying to get access to the application without a legitimate password. What are they looking for? Visit the secret login panel and bypass the login using SQL injection. Done. Okay, how many entries are there in the gift database? How many entries are there in the diff database? Are we looking here? Gift is null. So there's nothing in the gift database? Is that what we're supposed to understand? Okay, let's go back. So how many entries are there in the gift database? I think what we're supposed to do here is we're supposed to do some more SQL injection. Okay, the database is updated while you're away, so we're going to search for something. Toy? Okay, so toy car Charles. Great. Okay, so what we're going to do is we're going to do some more SQL injection. So we do toy union select null null, and we'll see if this comes back. If this comes back and we see the the gift and the child still, that means we've successfully done gift none and child none. Hold on. What we want to do is we want to use a union select statement to get extra information from selects to the right and left and right of the union do not have the same number of result columns. Okay, so this was actually 2 columns. Okay. So any way to get a query with the TXT or PHP? Any way to get every query with the TXT or PHP? Are you looking are you... I'm sorry, could you rephrase your question? I'm not too sure what you're asking for. So what we're doing right now is we're trying to use some fancy SQL injection to get access to additional information. So this would be something like select gift child from, I don't know, like a gifts table, where gift is like something. So this is where our injection is. So what we're doing is we're also closing out this one, and we're doing a union select. So it's basically trying to get additional information from the database. So union select null null. What we're doing here is we're just trying to figure out how many columns are being returned by the original query. In this case, it's 2. And we're going to comment out everything else by giving these special characters. So after we've figured it out, then we have to do a number of different things. I've got a guide for how to do very basic union SQL injection over at the HackerFrogs AfterSchool website for web app stuff. So beginner's SQL injection. So we need to do it in steps. So the first one is to identify the injection point. Then we need to figure out the number of columns for the union select. The next thing we need to do is we need to identify the database management system, which is the flavor of SQL being used by the web application. So for example, it might be MySQL, it might be MS SQL, SQLite. We need to figure it out because depending on what DBMS is being used, we need to use different commands to get extra information from the database. So we could put in version in order to figure out if it is MySQL or MariaDB or PostgreSQL. We could use SQL map as well, but it's important to understand how to manually compromise a database using SQL injection before we use automated tools. Okay, let's go back. So here, we're just going to replace the second null with the database command or the version command. Okay, let's see if this works. Okay, no such function version. So this is probably not MySQL. So we're going to try another payload. So our next payload is it's going to be this AT version. Just a second, everybody. I'm going to pull up another playlist to play for music. How about some StarCraft? Okay, so we're gonna try these next payloads over here just to figure out which DBMS is being used. Everyone knows it's Postgres. Does everybody know it's Postgres? I mean, we can give it a shot. Okay, version. Search that. Unrecognized token. Okay, so this doesn't work. We try another payload. So if you say that it's supposed to be Postgres. Wait, does it say Postgres? No, it didn't say Postgres. This should work if it was Postgres. MSSQL or MySQL. Sysdate from Dual. This is probably not MSSQL. We'll try SQLite. Oh, I just meant that Postgres is good. Oh, okay. Sorry, I don't do very much development. Okay, let's try this next one. Okay, SQLite version. Okay, so this is SQLite because it responded to that. So all of our payloads from now on they need to work with the SQLite. Okay, so now that we know that SQLite is the DBMS being used, we need to do the next thing. So the next thing is SQLite only has one database, so we don't need to figure out the other databases in the system. So we need to get the name of the current database. So it's Pragma database list. Okay, thank you very much for subscribing. 13 originals, thank you. Okay, let's give it a shot. So it's Pragma database list. No such column Pragma. I mean, no such column Pragma. How about union select? I mean, that should have worked, but I don't think we necessarily need to do this step right now. We need to find the table names in the database. So if we have access to the database, we can get the table names, and then after that we can find out information about those tables. So let's see. SQLite is name from SQLite where type equals table. We'll go back in. Need to spell the word where correctly. Okay, let's give this a shot. So we got hidden table, we got sequels, and we got users. Thank you very much. Slyborg is rating with a party of 39. Thank you very much, Slyborg. Everybody, did you know that Slyborg is another InfoSec streamer? Hippity hoppity hack. Hey, Sand Advice, thank you. Okay, let's give a shout out to our good friend Slyborg. So if you're into Minecraft, if you're into learning with somebody who is studying InfoSec, then definitely check out Slyborg's stream. Welcome in, Raiders. Hack the Planet. Thank you very much, Slyborg. And you know what? Let's go ahead and give us a Hack the Planet over here.
Hack the planet! Hack the planet!
Cybernoipy says, "Are you an InfoSec streamer?" Cybernoipy, I've seen you in my chat before. Are you an InfoSec? Yes, I am an InfoSec streamer. Thank you very much. Mr. Yellow Owl says, if you're interested in the best stream ever, Follow Slyborg, Mr. Yellow Owl. Yeah, no worries. I just shouted out Slyborg, and I'm pretty sure if there's a link that appeared, you can follow Slyborg for sure. All right, thank you very much. Welcome in, writers. We're just doing some SQL injection right now. We're working on this room right here. It's the TryHackMe Christmas event from 2018. You were doing, oh, Hack the Box. Oh, okay. Yeah, Slyborg. What were you covering on stream? Were you doing Hack the Box starting point or something different? Let us know. Okay, so how many entries are there in the gift database? The gift database. So we need to figure out how many items exist over there. So I think there's like the gift database. So what did we just find out? We just did some SQL injection. We found out that there's a hidden table, there's sequels, and there's users. So what we need to do is we need to get the number. So we need to get the count from users or something like that. Okay, Slyborg says, I was doing archetype. Oh, archetype on starting point. That's the Windows one, right? AI devs should use AI text-to-speech. They should use my voice? Yeah, that's the Windows one. You know what? If you managed to understand what was going on Architect, my hat's off to you, because that's not... For someone who's just, starting off learning about network pen testing, Archetype is not a very friendly box. And thank you very much. Yeah. Anyways, okay, so we need to figure out how many entries are in the users table. So I need to look up the command for SQLite. SQLite, the count function. So SQLite count is a function that used to count the number of rows or non-null values within a specified group or table. Okay, so we can just use the count function to count the number of entries in the users table. So this is how we're going to do it. We're going to go in, and we're just going to select null, 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 null count from users. So we're just going to access the users table, and we're going to count all the entries there. 1. What do you want? That doesn't seem correct. Okay, so there was a users table. What were the other? There was a users table. There were a couple of other tables as well, right? So there's sequels and there's hidden table. Let's try sequels instead. Okay, Slyberg says it was fun but took forever. I mean, it is a very fun box. You were doing some SQL hacking as well. So Slyborg, yeah. So the archetype box uses it takes advantage of MS SQL hacking. Okay, let's try looking at sequels. 22. So 22 might be the answer. We'll submit that. Okay, so that was the correct answer. What did Paul ask for? So something tells me that we need to look for this Paul user inside of the sequels. Inside of the sequels table. So sequels, I need to keep track of the tables here. So there's hidden tables, sequels, and users. Let me just copy that, and I'll put that in my notes. Okay, here. Okay, so the next thing we want to do is we want to figure out the number of columns in the sequels table. So how do we do that? Okay, so this is step 8. Output column contents from tables. No, determine the column names in the tables. So this is what we're doing now. Cyborg has been working on Hack the Box since May. Awesome, awesome. Okay, so we're looking for the command that works for SQLite. So pragma table info, your table name. Let's do that. Can we run pragma? Can we run pragma with the select statement? Let me find out really quick. So SQLite pragma select statement. You cannot combine pragma with the select statement directly in a single command. Pragma is a special command for SQLite to control its behavior. Okay, so you can use pragma functions within select statements to query internal information about a table. So what would that look like? Using pragma's functions with select. Select star from pragma table info. Oh, okay. Okay, I think we just need to adjust our payload a little bit. So it's pragma table info. Your table name. I think it's the table name is sequels. Okay, let's grab this. Cypher asks, what's your Hack the Box rank? It's something like 7,000. I can pull it up real quick if you want me to. Let's see, TryHackMe. Let me go up to the top. Whoops, that's just my that's just my guy. Hold on. Okay, let me. There's a rank on Hack the Box? Oh, Hack the Box. You're talking about Hack the Box. I don't really have a rank on Hack the Box. I have a rank on TryHackMe. Sorry, I thought you were talking about TryHackMe. My rank on TryHackMe is 7,000 something. It's less impressive than Hack the Box. Hack the Box, you need to work pretty hard to get a good rank. But in TryHackMe, you just need to complete a bunch of rooms. I generally don't use Hack the Box very often on my stream because I cover stuff that is free and evergreen, and Hack the Box doesn't have very much stuff that's free and evergreen. They have free stuff that is rotating all the time, and the stuff that is free I can't cover on my live stream. Cypher says, I reached Pro Hacker recently, not sure I deserve it yet. CyberNoIP asks, what is your rank, Slyborg? Okay, let me just add an hour to this. I'm pretty sure I'm getting close to the end of this particular day. Hold on. Oh, that's the wrong thing. Okay, so let's get this next thing. Where is it? Pragma table info sequels. Copy that, put it into our payload, and then search. No such function pragma table info. Okay, so we need to find some other way to do this. So SQLite. So SQLite select statement to get table column names. Okay, let's see what comes back. To get column names from SQLite, use pragma. Okay, so this isn't going to work. We have to use select. Okay, you know what I'm going to do? I'm going to use the payload playground. This is a pretty good place to craft SQL injection payloads. Okay, let's go ahead and do that. So if you're wondering what I'm looking at right now, this is a fun little tool that we can use. So the database type is... They don't have SQLite here. I guess it doesn't help us very much. Never mind. Okay, I'll try asking ChatGPT then. Okay, I want to get table column names from a SQLite system. I must use a select statement. Okay, rabbit hole. What are we talking about? Okay, let's see if we can get a proper answer from our good friend the AI. To list column names from SQLite database using only a select statement, you have to query the SQLite system table. Why are you telling me about this? Okay. Use SQLite master and pragma table info. Select name from pragma table info. Okay, I think we can give this a shot. We just need to plug in the correct thing. Okay, let's try this payload. Back here. Awesome, awesome, awesome. Okay, so we got age, kid, and title. Title? Age, kid, and title. So we're looking for the kid named Paul, right? Let's go back down. Okay, what did Paul ask for? I mean, we don't necessarily need to look for Paul. We can just dump out everything because there's only 22. There's only 22 rows. So we're gonna go back. And we can just plug in here. So select kid and title. Select kid and title from the table named sequels. And let's see what this gives us. How did you find the SQL Server version? I think I used this command up here. So what was it? Identify the DBMS used by the web app. So it was this one here, SQLite underscore version, this function. Okay, let's go back. Search. No such column kid. Wait, I saw age, kid, title. And we were looking in the sequels. Oh, we didn't do from sequels. Okay. All right. This works. All right. So we're looking for Paul. GitHub ownership. GitHub ownership. I guess that's the answer then. Okay. So we managed to leak out this one table. 10 McDonald's meals for Thomas. That's a TryHackMe subscription. Finnish to English dictionary. That's great. GitHub ownership. That's the answer we want. Done. What is the flag? Okay, so we should be able to look in the hidden table because we found one. So we found hidden table. We just need to get the name from hidden table instead of sequels. Okay, and we will do that to get the flag. Null syntax error. So union select. Oh, we didn't do select here. Union select. Okay, so there's just flag. There's only the flag column. So we just need to select union select flag, null flag from hidden table. Okay, do that. And we get THM Fox. It's looking kind of weird. So just to make sure that I'm looking at the correct thing, does this not appear? I wasn't able to look at the source code. That's alright. Okay, so let me just copy this, and then I'll submit this as the flag. Here. Paste in. Okay, and what is the admin password? Alright, so there was one last table. So the table was the users table, and there's only one thing in there. So I'm just going to guess. So username from tables, or username from users. Actually, password from users. Okay, go in here. Go in here, then union select username, password from users. Okay, so admin, and we've got this password right over here. Copy that. Go back here, paste in the password, and we're done. All right. Let's see. Ronan says, oh, I already read that one. His and hers spot. Him and hers spot. Hello. What is the page with Santa Claus for? So this is a CTF challenge. It's a cybersecurity challenge where we need to do different hacking activities for each day. It was originally part of an Advent event from this website over here called TryHackMe. And we've been working through these old ones from previous years to warm up for this one, for the one that's coming up in about a week or so. Saki asks, is cybersecurity a good career? It's a good career if you're passionate about cybersecurity. If you're only getting into cybersecurity because you hear that it's a good way to make money, and you're not actually interested in cybersecurity, you should stay away. Because there's some times where cybersecurity is a very good choice for work, because there's a lot of because they're hiring a lot of people to do cybersecurity work, and there are other times when cybersecurity is absolutely terrible as an option because nobody's hiring cybersecurity people. I'm not sure if we're going into like a good market for cybersecurity right now, but we've been going through a bad year for cybersecurity hiring for about the last year or so, unfortunately. What defines a good career depends on the person. If you do cybersecurity stuff and you find that the work really speaks to you, or the concepts really speak to you, and you're really like passionate about this stuff, then yeah, then it's a good career to do. Sick in the Mind says, so the reason it was a bad year. Sick in the Mind, do you have some insight as to why it was a bad year? Seki says, do you know VLSI? VLSI? Not too sure about that acronym. What does it stand for? Are you talking about very large-scale integration or something else? Okay, so I think we might be able to do one more challenge depending on how difficult it is. This is probably going to be the last exercise we do today. But let's go ahead and get started. Very large-scale integration, basically chip design. I mean, I don't really know too much about hardware. What I focus on is software and taking advantage of software systems. Stuff like web applications. I know very little about hardware. Oh, we're doing cross-site scripting. Okay. So cross-site scripting is another one of those really common, well, this is a very well-documented type of vulnerability. It's basically doing JavaScript injection, forcing applications to run JavaScript code. Thanks for the explanation on Santa. So the web browser that you're using is almost like a virtual machine. So, I mean, I'm using the machine that I'm using right now is a virtual machine, and it's running a version of Linux. So this is a version of Linux with a bunch of security tools installed on it called Kali Linux. And the web browser that I'm using here is inside of the Kali Linux machine. I'm connected to a virtual network, to a virtual private network rather, that is hosted over at TryHackMe right now. And I'm accessing their challenges through that VPN connection. Sick in the Mind says, Sick in the Mind has some insight. Layoffs in government agency cyber folks. AWS got rid of a bunch of cybersecurity peeps a year ago. CISA lost a bunch of people. MITRE lost quite a few people. And there's a lot of people that were hitting the market at the same time. Sick in the Mind says it should level out next year. Yeah, those companies too. CrowdStrike, Deepwatch, Axionius, Bitdefender, Aqua Security, layoffs. Sorry to hear about that. Okay, so are they asking us to use Zap? I haven't used Zap in a few years. But they're asking us to do some automated scanning, I guess. Interesting. Okay. So start the attack box and then look for the web browser for the web server on port 5000. Okay. Let's go ahead and access the browser then, or access the web server. Okay, we've got an IP address. Oh, we need to make sure it's port 5000. Okay, and welcome to Santa's official Make-A-Wish website. You can anonymously submit your Christmas wishes and see what other people wish for too. Enter search query, enter your wish here. So if this particular application is vulnerable to cross-site scripting, like it says, then we could put in a XSS payload. So it's basically a JavaScript payload. Yeah, let's see if this works in the search field. So something like some script tags, script / script, and then in the middle we'll put in our payload. So alert XSS is here. Okay, and we'll submit that. It works. Ranch asks, what CTF is this? I'm doing an old advent of cyber on TryHackMe. TryHackMe is something new. I mean, I really like the advent events. So we've got cross-site scripting, great. They've got 5 years of previous advent event stuff. So if you really wanted to get a good overview of a bunch of different stuff you can do inside of cybersecurity, this one isn't the best one because most of the stuff is web app hacking stuff, followed by a bunch of network hacking stuff, followed by a little of... Actually, no, it has some good stuff here too. It's got reverse engineering and scripting as well, some OSINT. Yeah, this one's pretty good. Well, as far as at least as far as the variety of challenges goes. Sick in the Mind says, Zap is cool, but Burp Suite is still my go-to. Yeah, I mean, even though there's a lot of limited functionality for Burp Suite free version, I still use it a lot. But I'm pretty sure OS Zap is installed on here by default. Zap. No, there's no Zap. Huh. I have to manually install Zap if I want to use it. That really that makes me not want to use it. I'm a Kaido convert. Kaido. Is Kaido installed in here by default? I'm pretty sure it's not. Kaido. Okay, I'm pretty sure I'm going to have to use some other method to install Kaido. But what do we have on this website? And what do they want us to do? Just a second. Okay, so this is day 6. Cross-site scripting. What vulnerability type was used to hack the application? So this is... I'm going to say this is stored cross-site scripting. Because they've got a section of this website where you can inject stuff here. So we can put stuff into the application and store it in the database. Kaido's still missing a lot of burps features. I'm sure Kaido will catch up. It's going to take some time though. Okay, so another thing we can do with cross-site scripting is we can inject HTTP tags. So this is small text. This is big text. Okay, so this is big text and this is bold text. So what we can do is we can include our HTTP tags in here. So we can activate bold here. We can give it P1 here. Okay, so the big text didn't, but the thing is that the HTTP tags are being interpreted when you put them in, which is another sign that it might be vulnerable to cross-site scripting. Okay, and what else do they want us to do? Which query string can be abused to craft a reflected XSS? Which query string? Launch the OS Zap application. Yes. Which query string can be used to abuse a craft a reflected XSS string? What are they looking for here? So it's a single character. Tardigrade, will you do hardware hacking? I mean, I would like to do hardware hacking eventually, but I would really like to do a few more categories of software hacking first. Plugins, which query string, craft a reflected XSS. So we're looking for a single character, search query, test, Q. Oh, Q is the search query. Okay, so we just need to put in Q, I'm pretty sure. Q. Launch the OS Zap application. Run a Zap automated scan of the target. How many XSS alerts are in the scan? Okay, I'm a big fan of the Auth Matrix plugins. Are you talking about Kaido, or are we still talking about... Are we talking about Burp Suite or Zap? I'm pretty sure we're not talking about Zap. Fernosec says, only thing I have to load up from Burp is for the desync checking stuff, okay. Okay. So, explore the XSS alerts that Zap has identified. Are you able to make an alert appear on the... Are you able to make an alert appear on the Make-A-Wish website? They're not... They don't want us to get a flag. I guess it's kind of hard to get a flag using cross-site scripting. His Inner Spot says, just wanted to say I'm excited to have found this channel. Me and my girlfriend are enrolled in school for cybersecurity. Oh, awesome. Everything seems like a lot of gibberish, but we know watching live streamers like yourself would help us learn and gain experience. Yeah, no worries. If you have any questions about any of the stuff that we're doing, please let us know in the chat. I don't want anybody to feel lost. And if, you know, and as a person who's trying to teach cybersecurity, I need to know when my explanations have to be better. So if there's anything you don't quite understand, please let us know. Okay, so how many XSS alerts are in the scan? I don't know. I'm just going to have to give it a guess. Because I'm probably not going to be... I don't want to install Zap proxy and then run it. It's going to take too much time. It's a single digit number, so we can just kind of brute this. 4. No. 3. Oh, you're going too fast. Okay, they've got brute force protections. They got brute force protections in the application here. That's funny. Okay. Answer is incorrect. Okay, so 4 and 3 were not correct. How about 2? Wait, 1, 2, 3, 4, 5. Okay, it's 2. Alright, so we're done. I think we might do one more challenge before we end the stream. But I think I'm done with the Christmas challenges for right now. Okay, let's terminate the machine. And you know what? I've been wanting to do more challenges over at this website over here. So RingZeroCTF. It's a pretty nice alternative to some of the other CTF websites that are pretty popular. And let's see. We'll do one from... Which category should we do? How about we do a coding challenge? Then coding challenges take a long time, though. Okay, but do we... Wait, we're not logged in. Okay, let me log in. RingZero has been around for ages. Yeah. It's also associated with a conference. I think it's called NorthSec. Okay, let's see. So the next easiest one is HashMe Reloaded. let's give this one a try. Oh, we already did the I hate mathematics. Hash me reloaded. Okay. So we're going to go to the challenge. Alright, so everybody, if you want to take a look at this challenge yourself, it is over here. I have a feeling that I'm going to be able to use the same sort of script. Oh, what the heck? This is just a really big binary number. Alright, thank you very much, his and her spot. Thank you. Thank you very much for following on Twitch. So we got you have 2 seconds to hash this method using the SHA-512 algorithm. Send the answer back to here. Okay, so we did a challenge that was very similar to this a couple of days ago. And let me just grab the script that we used for that challenge. Okay, so for anybody who doesn't know, we record all of the solutions for the CTF challenges that we do over at the HackerFrogs GitHub. So in this case, we're going to go over to RingZero, Coding Challenges, Hash Me Please, and let me just grab the script that we used for that challenge, because I've got the feeling that we're going to be doing something very similar. Okay, and let's call this new script RingZero RingZero.py. Okay, we'll paste in the script that we did for the previous challenge. I'm going to set up a little coding environment. So my coding environment is very, very basic compared to everybody else's. It basically involves me opening up 2 terminals. One terminal will run the script, and one terminal will be used to write the script. And thank you very much, Noor Salam. Thank you for following on YouTube, or for subscribing on YouTube. Okay, so where are we? Here and there. Okay, so here it's going to be a very similar environment. We need to do some hashing, and we need to make some requests, some web requests. So the URL that we're going to contact is going to be different because this is a different challenge, and the URL that we're going to be sending to is also going to be different. Okay, so let's go and get those 2 things. We're not doing Santa stuff. Here. So this is the web page that we're contacting. So I'm just going to plug this in to our URL parameter here, or our variable rather. Okay, and then we need to send it back to a different URL as well, which is here. Okay, and then, so we're going to be workshopping this script, and we're just going to make sure that we get the server response okay. So I'm just going to comment out everything in the script while we're trying to figure this out. We're just going to print out the response. So we're going to print out response.txt. Okay, and then we run the script. Okay, so we get this binary blob over here that we need to encrypt, that we need to hash and send back. So we managed to identify the stuff that we need to send back over here. We need to isolate the data that we want to transform. So we just need to identify where the really big string of binary numbers appears. Okay. And then we will print out the this list that we create over here. Actually, we're going to print out this longest item that we define. Print out the longest item. get rid of this other print command, and then run the script. Okay, so we've isolated this really long binary number. We just need to clip off the last 3 characters here, and we do it by defining this, the formatted item. Okay, so I'm gonna finish this challenge off, and then we'll finish off the stream. So the formatted item is this. This should work like it did in the previous challenge. We're just gonna clip off these 3 characters here, and then we need to convert the string to bytes. Okay, bytes data equals formatted item dot encode UTF-8. So we also need to so this is a little bit more complicated. In the previous challenge, I'm pretty sure we were dealing with. Okay, let me take a look at the previous challenge just for a sec. So the original HashMe challenge, this was a, what is this? This is a base 64 encoded string. So this time we're dealing with the binary string. Okay, so bytes data equals formatted item dot encode into UTF-8. But in this case, we don't necessarily want to encode from UTF-8. We want to do SHA-512 hashing. So Python, oh, my music ran out again. Okay, one last little playlist to play until we finish. Just a sec. Okay, here we go. Okay, so we're doing Python SHA-512 hashing with integer, because you know, like a binary number is an integer. To perform a 512 hashing on an integer in Python, the integer must be converted into a byte string. Okay. So import hashlib, integer value equals this, and then byte string equals integer value 2 bytes. Integer value dot bit length equals 8. Calculate the minimum number of bytes required to represent the integer. Byte order big specifies big endian byte order. And then we need to create a SHA-512 hash object. So what if we're specifically hashing with a binary integer? Okay. So steps for hashing a binary integer: convert the integer to a bytes object. Gee, this got a little bit more complicated, didn't it? We create our own function, really? Computes the SHA-512 hash of a binary integer. We need to specify the integer value. We need to do the byte length. We need to do the byte order. Computes the SHA... Okay, so first of all, we need to make sure that our formatted item is convert binary number, binary string to integer, because this is not an integer. Whatever this is probably going to be a string. And Python really cares that we're not, it really cares about operations, the data types when we do the operations. So binary number, actually binary int equals formatted item. We need to run the integer function on it, and we need to specify that it is base 2. Okay, and we're just gonna be very explicit about this. Print binary int, and then type of binary int. Okay, and then we will go back. This is an integer. Okay, well, what happened here? Oh, okay. Oh, okay. I see what happened here. So, so it did the conversion. So the binary integer was converted to decimal, and this thing is, yeah. So this is decimal now. So if it's decimal, then we can just do like a regular like integer, like an integer hashing, right? Okay. So hashing with just a regular integer. I guess in this case we don't need a whole like big old function for it. Okay, integer value, integer string. We need to convert the integer to a string? What? Oh, geez. Encode the string to bytes using UTF-8, and then create the object. All right. I mean, I guess we're kind of moving. Convert the binary string to integer, then to decimal string. Okay, so we get the binary integer, and then we need to do a decimal string. So the decimal string will be string of binary int. No. Yeah, string of binary int. Okay, and then convert the string to bytes. This should be the same as we did for a previous challenge. So bytes data equals, this time is going to be decimal string dot encode. Decimal string dot encode. Then run the hash function on the data. Then send the response back to the web page. So before we do all of this stuff, I just want to see what this looks like. We're going to print off the hex digest. Okay, just to make sure this works. Okay, so the hex digest looks good. We just need to send this back to the server, and then we will be completed we'll have completed the challenge. Okay, so get rid of this and run the script. So if the script runs correctly, it will extract the binary number and then convert it to decimal, and then convert it into a string, and then do the hashing. After the hashing is done, we send the response back to the specified URL with the hex digest, and then get back the flag in the response. Okay, so we should see the flag somewhere in here. Maybe near the top. Wrong answer or too slow. Huh. That's... I guess I did it wrong. It says wrong answer or too slow. Let's run it again, just to make sure that Was it expecting wrong answer or too slow? So this challenge, it is expecting like the hex digest. So I'm not too sure why it doesn't accept the answer. Or is it looking to, or do we not need to? You don't need to base64 encode the data? I think the challenge isn't amazing. You don't need to base64 encode the data. I mean, the previous challenge, we did it with this script, well, like a modified version of the script. The only other explanation could be that what we need to do is we need to take the binary, we need to take the formatted item, and we need to just directly hash that. So let me try commenting this all out. And we'll just do formatted item dot encode. So this will be, the formatted item is just this string of binary numbers. So Furnacex says you shouldn't be hashing the message string. You should be hashing the message string, not taking the message, decoding it, and then hashing that. Oh, okay. Yeah, okay. I think this is what I'm doing with this next version of it. Okay, so hash object equals, okay, I think this is all good now. It should be all good now. Let's try it again. Was it correct? Wrong answer or too slow again? Okay, so bytes data, formatted item is this number, and this number is binary, like a binary string. I wonder, okay. So SHA-512 hashing with binary string. You must first convert the string of zeros and ones to a byte object. Okay. Int binary, so convert the binary string to an integer. I mean, we did this version. This version converting it to regular integer, like a decimal. We did this. Convert the integer to a bytes object. Oh, but yeah, okay. This is slightly different. So we didn't turn the integer into a string in that case. Convert the integer to a bytes object using the 2bytes method. You'll need to specify the length in bytes and the byte order. And then we've got convert the binary string to an integer. We did that. Calculate the number of bytes required. Length of the binary string divided by 8. Okay, so I guess we need to calculate all this stuff. Sure. So in this case, we're converting the binary string to an integer, and then so we're not doing the decimal string in this case. Furnacex says, because I'm a terrible person, here's my solution after you're done. Yeah, I mean, did you get the flag already? It may be a tad golfed. What does the word golf mean in this case? So byte length equals, what are we doing? Length of binary string. Oh. Length of, in this case I guess, convert the binary string to an integer. Length of binary string divided by 8. Code golf is where you try to shorten the source code. Okay, okay. So in this case, length of the string, convert the binary string to an integer. The formatted item. So length of formatted item divided by 8. Calculate. Calculate hash parameters. So we got our byte length and we've got our binary bytes. So convert the integer to a bytes object. So we do that over here. Convert the binary integer to bytes. Binary bytes equals this thing. Oh, I might as well just copy the whole line. Okay, so binary bytes equals binary int. Where was that defined? Binary int dot 2 bytes, byte length, byte order big. Okay, so then run the hash function on the data. In this case, it's hashlib.sha512 on binary bytes. Okay, let's. I'm probably going to get some sort of error. All right, let's see if that worked. I got the flag. We finished. Okay, so let's. We don't need this. Furnos, Furnos did a different challenge. Which challenge did you do? I did the other one. Oh, you did the original one. So the original one, yeah. The one we're doing now, it's so this is hash me if you can. Yeah, so this is the first one. The second one is over here. What is it called? Hash me reloaded. And it's located. The only thing that's different here is the port that you're accessing it on. But the response is supposed to be sent over here. Okay, everybody, we finished the stream on a dub. That's great. It's always a bit disappointing to not finish the challenge that you're working on. All right, so before we go, let's talk about what we're going to be doing with the rest of the week. So we do 3 streams per week over here at HackerFrogs, and let's just pull up the Reddit. So if you don't know, we've got a Reddit over here, over at HackerFrogs. Usually look at my golf solution for giggles. Oh, sure. Furnosec, thank you. Let me take a look. So paste bin. Yeah, let me copy that. Okay, let's take a look at Furnosec's solution. Oh wow, this seems pretty optimized. Let me copy that. Okay, and so we'll call this furnos.py. Paste it in. Yeah, this does seem, yeah, it does seem pretty golfed, as you like to call it. Okay, let's run the script. Furnos. Ah, okay. So what does it do? So it gets only the line of text that has the word flag in it. This is pretty cool. It's pretty cool that you grep out the flag from the response. That's pretty cool. And Hunter Hamster, hello, nice to see you here. New here, no worries. Yeah, so Hunter Hamster, what are you doing? Well, we just finished a coding challenge, and we're going to be finishing out the stream pretty soon. But you know what? You're on YouTube, so you can watch the stream from the beginning if you want to. It's pretty easy. But before we go, we'll talk about what we're doing over on HackerFrogs. This is just one stream of 3 that we're going to be doing this week. So we do a stream on Mondays, Wednesdays, and Fridays. They're all at roughly the same time of day. And yeah, so today was Monday. The next stream is going to be on Wednesday. We're going to be doing web app stuff. When are we not doing web app stuff? But we're going to be doing some cryptography challenges. We're going to be doing some network hacking. We're doing a new course. We're going to teach everybody how to get started doing network hacking so that you can start doing challenges like Hack the Box and TryHackMe. That's going to be on Wednesday. We're going to be doing more web app demos, and we're going to be doing some challenges from the TryHackMe platform. That's on Wednesday, and on Friday we're going to be doing a lot of coding stuff. So we're going to be doing coding challenges, we're going to be doing reverse engineering stuff, and we're also going to be doing more variety, I guess. Variety cybersecurity stuff. All right. So everybody, what we like to do on this channel is we like to do Hunter Hamster says I'm going to get an Arduino for Christmas. Arduino. That sounds familiar. That's what kind of hardware is that? Arduino. Oh, okay. I see it. So it's hardware stuff. Awesome. Okay, so what we typically like to do here is we'd like to take a look and see if there's any cool InfoSec streamers on. And InfoSec streamers has a bunch of people who do InfoSec content over on Twitch and YouTube. So we got myself, I don't know who Nemax is, but there's Slyborg, there's Panko, BlazeBits, a bunch of good creators. And if you want to discover new InfoSec creators, this is where you do it. But aside from that, we should probably raid somebody on Twitch. Let's see who's on. Oh, Science Streams is on. We got Science Streams. We also have, let's see. So I'm pretty sure you would appreciate the Science Streams. Let's take a look at what they're doing. Science Streams does a bunch of science content, and I'm sure that everybody here is super interested in science. What are we doing here? So microscopy Mondays. So tiny worlds under the microscope. Okay, this seems like a lot of fun. Pumpkiny Jr. Your preferred OS? I mean, I use the OS that's given to me. I like using Linux. I'm okay using Windows as well. Either one is fine. All right, let's go ahead and start a raid over to Science Streams. Raid may cross copy. Science. Okay, so we're starting that raid right now. When you arrive on the channel, please give this message over here. OS Frog, hip hop hack, OS Frog. Golf the second one. Of course. But, okay. Before we raid, we will check out the second script that that Furnos did. Okay, let me go ahead and get that. Just copy everything. We go in here. And it works. Awesome, awesome. Thank you very much, Furnosec. Which distribution, Linux distribution, are we doing? We're doing, what was it? Kali Linux. So Linux, Kali Linux. This is a Debian distribution. But anyways, let's go ahead and raid. Everybody, we'll be back on Wednesday. Hope to see you then. Thank you very much for everybody who came around and commented. I appreciate you all. Everybody, science streams ready in 5, 4, 3, 2, 1. HackerFrogs out.